Shiva. Shiva sir. EP Shiva. EP Shiva sir. Radha, post பண்ணு Radha. Shiva. Sir வந்துட்டார் sir.
Yes, he's coming.
Good evening, sir. Sir, good evening, sir.
Yeah. Sir, good evening.
Good evening sir. Good evening sir.
Good evening, sir.
Good evening.
Shiva post பண்ணு Shiva.
Sir, சொல்லுங்க சார்.
Post கொஞ்சம் பாத்து நான் என் லேப்டாப்ல இருக்கா சப்போஸ் வந்துச்சு ப்ராப்ளம் வந்தா.
ஓகே சார். நீங்க போட்டு விட்டுருங்க சார், நான் பாத்துக்கிறேன்.
விஜயகுமார் டிவிகே
நீங்க கோஹோஸ்ட் போட்டுருங்க, நான் பாத்துக்கிறேன் சார்.
சார் வணக்கம்.
ஓகே சார், கோஹோஸ்ட் வந்துடுச்சு சார். ஓகே, ஐ வில் டேக் கேர்.
Bapuji.
Sir. What is it? Sir, சொல்லுங்க சார்.
Sir, now it is audible?
Yes, sir.
Oh, even audible illam irundhathu. So okay.
Okay, sir. Good evening, sir.
Okay, sir.
Okay, let us start.
Yes, sir.
Now time agala polukudhe. No 3 minutes irukka illa irukke.
1 minute, sir.
1 minute, sir. Oh, people should not take that we have started AD illa. So today is the first day, va?
Yes, sir.
Actually, President College la kalayila indha seminar mudichittu vara vendi. Actually 2 seminars இன்னைக்கு மார்னிங் அங்க வருது. நான் வரதுல ஆரம்பிக்கலாமா இன்னும் கொஞ்ச நேரம் போட்டுமா? ப்ரொஃபசர் என்ன சொல்றாரு? இவர் என்ன சொல்றாரு?
சார் ஹெச்ஓடி
ஒரு ப்ரொஃபசர் கோவிந்தராஜனை கேளுங்க என்ன சொல்றாரு.
இந்த கேட்றேன் சார் ஒரு நிமிஷம்.
We can start, Vardarajan.
சார் இந்த
We can start.
Oh,
one minute sir. One minute sir.
ப்ரொஃபசர் கணபதி, குட் ஈவினிங் சார்.
Good evening, Professor.
ரொம்ப நாள் ஆச்சு பார்த்தலாம். மறுபடியும் சிட்டிங் இந்த ஹோம் அண்ட்
லாக்டவுன்னால எங்கேயுமே போக முடியல.
கரெக்ட்.
Confined to the four walls.
கரெக்ட்.
House arrest.
ஓகே
சார் one minute.
ஓகே சார்.
One minute sir. Sir.
Introduction, sir.
Sir.
ஓ, இன்ட்ரோடக்ஷனா? சாரி. ப்ளீஸ்.
சார் HOD சார் இருக்காங்களா?
என்னம்மா?
சார் ஒரு நிமிஷம் சார். சார் HOD சார்.
சார் HOD சார்.
ஒரு லிங்க் வரல Vardarajan.
சார் ஒரே ஒரு நிமிஷம் சார்.
ரைட் மா, நோ ப்ராப்ளம்.
ஃபர்ஸ்ட் டே சார்.
வரட்டும், வந்தோனே
ஸ்டார்ட் பண்றேன்னு சொன்னாங்க.
No problem. Let him come.
Yes sir.
Probably has gone on some urgent work out.
Yes.
இல்ல காபி குடிக்க கூப்பிட்டாங்கன்னு நினைக்கிறேன், போயிட்டாரு வேகமா. காபி குடிக்காம வந்துட்டாரு, அதான் வீட்டுல கூப்பிட்டாங்க போறீங்க.
Chengalpattu is having severe lockdown. All the colleges are almost closed. To make use of this period in an effective manner, our management has given instruction to organize such programs for faculty members separately and research scholars separately. We are informed only on 2nd of July, and we could prepare the list and prepare the resource persons by 4th, and we fine-tuned for the next 2 days. And today we are having our special person with us. Our department is going to conduct 2 programs. One is faculty development program for the staff members from today 6th July to 16th of July, and we have identified 15 resource persons for giving the talk. And our next program will be research development program for research scholars, and we are identifying the resource persons. Till now 11 have agreed to give the talk. That duration will be from 17th of July to 28th of July. So this is the situation. So on behalf of our Department of Mathematics, I welcome Professor Venkatesan, who has accepted to give the talk on machine learning approaches for mathematical modeling. And for SRM faculty, for KTR campus Maths Department faculty members, this program is a must. All the faculty members have to attend. The entire program is recorded, and it will be shown to the dean, pro VC, and etc. We thought of inviting our pro vice chancellor for saying few words about the program. Unfortunately, it's not available. That's why I could not get him. We'll try to get him on research scholar program. Okay. So with these few words, I request Dr. Vardarajan to give a brief introduction about our speaker to the audience. Vardarajan, please.
Yes sir. So good evening to one and all. It's now my great pleasure to introduce Dr. P.Venkatesan, retired scientist, Senior Deputy Director, ICMR. He is currently working as a professor in Ramachandra University, also advisor, research and statistics, Child Trust Hospital, RA, Chennai. So Dr. P.Venkatesan graduated from the University of Madras, Chennai, with a Bachelor of Science degree in Mathematics in 1973. He received his Master of Science in Mathematics Statistics in 1975, MPhil Applied Mathematics in 1979, and PhD in Survival Analysis in 1988 from the University of Madras, Chennai. Also, he has completed PGDM, Post-Diploma in Data Management in the same university. Dr. P.Venkatesan completed PG Diploma in SQC and OR, MStat in Indian Statistical Institute. He also completed Master of Population Studies in International Institute of Population Science, Mumbai. Sir also completed his postdoctorate training in machine learning, computational biology, geographical information system, and biomedical ethics in Brown University, Province, Rogade, Island, USA. Sir also received fellowship from various university and various society. He has served more than 40 years in the field of teaching and research. He has conducted 15 national health survey, Sir also completed 20 projects as a investigator and co-investigator. Sir is a visiting faculty in various universities like Center for Statistical Science, Brown University, USA, Sri Ramachandra Medical University, Chennai.
Goindarajan, what happened?
Sir, am I audible, sir?
Yes, yes.
Yes, audible.
Yes, sir. Sir is also working as an adjunct professor in Manipal University, Manipal. He has graduated, he has guided 45 scholars to the award of PhD. Also more than 83 MSc, MPhil, MTech projects. SAR's main research area is disease modeling, HIV/AIDS projections, computational biology, artificial neural networks, and Bayesian inference, and more. He has published 350 articles in various scientific journals and book chapters. He has 500 plus presentation in various national and international conferences, including invited talk. SAR received various awards. I'm going to give a few only. So, Young Scientist Award by Indian Society for Medical Statistics, Renowned Teacher Award by Rotary Club International, Chennai, Lifetime Achievement Award by the Tamil Nadu Dr. MGR Medical University for the exemplary contribution to the cause of medical education and health research, and more. SAR has visited many countries, USA, UK, Italy, Germany, and also has membership in various professional bodies as a President, General Secretary, like International Biometric Society, Indian Society for Medical Sciences. Whatever I have given here, that is few about only, sir. So if I have missed anything,
Okay, it is already very lengthy thing. Okay,
sir.
Okay.
Over to HODs.
Okay, yeah. We'll start.
Just a minute. So, such a great personality is with us today for giving lecture. So I request Professor Venkatesan to start the lecture, sir. Please, sir. Please.
Thank you, Professor. Good evening to all. Yeah, really, it is a pleasure and privilege to be part of this program. Particularly, I am the opening batsman, so you put it. So accordingly, I am going to do it. So what I thought was, instead of talking the conventional thing, what are the recent developments, particularly in the modeling part, and how the machine learning has penetrated into our discipline, particularly when you are dealing with high-dimensional database. That is the whole idea. Just I'll try to give some important thing. I won't give all derivations, everything. It is only to introduce the topic and what are the recent developments that has taken place. And lastly, I'll try to end up with some of the open problems where I think those who are interested can be able to do it, correct? So with this background, I'll start with the first one. So the plan is something like this. We'll talk about first introduction, what is the machine learning. Then we'll try to say, particularly I'm going to concentrate more on the high dimensional modeling part. Then what are the ML applications, machine learning approaches for this one. We'll try to discuss about some hybrid models. Lastly, we'll try to give some applications which we have worked out on, which are published. So what is machine learning? All of you know machine learning is a part of the artificial intelligence. In fact, it is the main part, it is the heart of any artificial intelligence. So by machine learning, you mean the system that can be able to learn by experience. But when new data, new thing is coming, whenever additional data is coming, then by it learns to experience, correct? The machine learning, data mining, and statistics have similar goals. That is all of having modeling of classification, hypothesis generation, or testing. So start with statistics. All of you know it is traditionally it is involves analytically, particularly deals with the generalized linear model, general linear model, generalized linear model, general additive models, and the whole idea is so it drives both. It is in terms of restriction of for the power and the parametric distribution are heavily used, particularly estimation of parameters. When you are using parametric distribution, there are a lot of assumptions involved. That is one of the major problems. So to check the assumption in certain cases is very difficult. And most of the times, no real data satisfy more of the assumptions. But what you are having moderately satisfying is okay, but if it completely violates all our estimate parameters are going to be completely what we call not reliable or not. Statistics basically deals with three things. One is what we call the identification of the problem, the estimation, and it is going to be the formulation of the problem. But the identification of problem in mathematics and statistics is very difficult because we don't know, given in information and data, what is the actual model for this one? We don't know. Everything is only indirect check. There is no direct check for this one. But machine learning basically deals with quasi-parametric models, and to some of these models are closer to the human representation on the problem domain per se. To give some example, what is the, suppose you take, I think all of you are familiar with this one. You take one image, in terms of this one, so we are going to have the dimension in terms of matrix. So it is going to be in the gray image, it is 256 by 256. That is one image, gray image, black and white and black image. If you take it in terms of pixels, the variable number of variables which are going to be maximum 65,536. If it is there, what we call black and white image. Suppose it's going to be color image, it is power 3 because RBG, 3 colors are basic colors. So you are going to have red, you are going to have green, you are going to blue. Then the number, think of the number of variables. Suppose image is very simple because everybody is having the image. Suppose you are having, you want to identify based on certain medical application where about 100 cancer patients are there, 100 non-cancer patients are there. Totally, we are having only in terms of variables or in terms of equations. We are going to only about 200, 100 at the maximum. That is will cost so many million rupees. So what we are going to do is, then the number of variables you are going to have, even if we take a 120 by 120 matrix, the number of variables could be more than 2,000, 3,000. Then the basic problem we are facing here is the number of variables are going to be more than the number of equations or the cases. How to solve it? Suppose we are having, so this is a simple image. The next one, the microarray. So we are having microarray is one of the biomedical experiment where using a microchip, we have been able to get the information from any of the individuals, anywhere from 6,000 to 15,000 or 20,000 genes. So the main problem here is, suppose we are having, I want to identify which are the genes associated with the particular disorder. I got 15,000 gene information of a set of individuals and the same set of individuals for normals as in cases. Maximum I can able to get 50-50. That's the thing. That is 50 cancer, 50 non-cancer patients, but the number of variables which are going to take is going to be 15,000, anywhere from 6,000 to 15,000. So how to identify this one, how to solve the problem? So that is the second. Third, we can able to give, the data is given here. There are 60 cases where about 7,120, the data is available. Freely you can access it. You can able to see 60 cases and 7,000 features. So how to, it is central nervous system. So this is the major problem. So you are having 10 equations with the 10 variables non-determinate, we can able to solve it use no problem because we know all the methods. On the other end, if you are having statistics for having 10 variables, I need at least 100 or 200 cases because the number of cases will be more than the number of variables in statistical analysis to capture the underlying variation, correct? Whereas here, my number of variables more than the number of cases. That means solving is a big problem for us. Here only the concept of machine learning helps us how to solve the problem. So otherwise, we don't need other things, because a lot of, similarly, some of the other data is available. You can able to see there are 127 cases where the information available 2,500 variables. You have to, so the next one, the gene expression cancer, we are having about 7,000 cases, 50% are cancer, another 50% non-cancer. About 2,000 variables are there. This data is public domain available. You can easily download, you can try it. That's not a problem. On skin database, here is a big database in the sense, we got about 10,000 images, cancer images, normal and cancer images. That is the highest level where the classification problem. Based on this one, you have to identify whether the patient will progress for cancer or non-cancer. So, in terms of variables, we're having how many variables? Even you take the simplest scale, 128, 20, 16,000 variables, but already we said 65. Normally, the data file contains of 128, 250, all the matrix of values are available. It is about 16,000 variables. How to solve the problem? The next one is, now it is another major problem where we are going to have the individual, it is not one time point, or the previous data are one time point, where 240 patients have been done, they have been treated, they are followed over a period of time, where the median follow-up is 2.8 years, that could be anywhere from 1 year to 10 years, different follow-up period is there. And there are 240 patients, 132 patients developed the income. In other words, the individuals have been taken, they have been treated, still the patient will get disease, correct? So this kind of thing, 132. Similarly, data, yes? Can you able to hear? No problem, is it? Can you able
Yes,
to
sir.
hear?
We are able to hear.
Yes, yes,
We are
yes.
able to hear,
Okay.
sir. Yes.
Any problem? Just similarly, Dutch-based data. This data is a public domain available. Here also we are having 295 patients where the study has been followed for median follow for 6 months. So that means it starts somewhere from 3 years to 15 years. The range 0.5 years to 18 years. And there are 75 patients. Now, how to model this one? This is a major problem where our conventional methods all fail. So, what are the challenges? Just given some example to see what are the challenges you are facing. First one is it is high dimensional database. By high dimensional database, the number of variables are always more than the number of equations or the number of cases. That is the first thing. And if you take the public domain data, for example, cancer data, everything, it is a huge volume of data. Even a conventional computer, we cannot be able to download it, because that means we are going to take only segment of the data by part, then we are going to analyze and we are going to link it using certain algorithm. That's the first thing. The second important thing, all your X1, X2, etc., they are highly correlated variables, because biologically, most of the time, these variables are highly correlated. But most of our mathematical and statistical methods demand that they should be independent. That is not there. And one of the important things, particularly in statistics, what you are trying to do is the data analysis. You will start with an hypothesis, you will frame the hypothesis, you will plan the experiment, then you correct the information, then use appropriate methods to test and answer the question. That is, data is collected as per the hypothesis which you keep in mind. But most of the time, the data available in public domain, they are not collected with any specific hypothesis. Even that is a major problem with the data mining also. Everybody is sequencing, they are depositing like a waste paper bag. So there is no hypothesis behind the data which have been available in the public domain. What you have to do is you have to generate the algorithms to see whether any interesting pattern is there in the otherwise available data, so that you can generate hypothesis. Then you have to analyze it. Of course, the last major problem I said, the number of variables are what you call more than the number of cases or the number of equations in mathematical sense. So these are the challenges. When this kind of challenges, the only way is how we can approach it. Here only the concept of machine learning helps us to do it. Otherwise, conventionally, we are having 10 variables, 10 equations, or 10 variables with 100 cases. I need not go for any of the things, because very good methods are available. Whenever the data dimension is going to be very high and the cases are going to be very low, which breaks most of our assumptions, then here only the concept of machine learning helps us to come for the competition. Correct? So what are the things? There are dimensionality. There are two important aspects. One is, given a number of variables, we know the number of variables are going to be more than the number of cases. Then what we are trying to do is there any way the information contained in the large number of variables can be condensed to some minimum other number of variables, what we call the transformation variables. Suppose I got 2000 variables, I use certain transformation technique so that the information contained the 2000 variables are transformed to some latent variable concept, where about 10 or 15 or 20 variables can be able to capture a lot of information. Instead of using 2000 variables, I can use only the 20 or 30 or 50 variables, so that it will be easy, because the cases are going to be more than the number of variables. We can use any of the variables, correct? Then the other one is the selection method. The selection method is, among the 2000 variables, instead of having no transformation, among this one I want to take the best subset of variables. Suppose instead of having all the things, just like electing one MLA or MP, I am going to say, what is the best subset of variables are going to do it. So the linear approach, there are two approaches for this one, the transformation. There we are on the linear approach. The linear approach, basically one of the classical techniques from 1950, the principal component analysis. So what the principal component analysis says means, if there are n variables which are highly correlated, they can be done, each one we can transform it in terms of the principal components 1, 2, 3, 4, etc. Component 1, what we call the latent variables, where the first variable is capable of getting more information from most of the information contained in the n variables. Then the second variable remaining maximum, etc. So within a finite number of about k variables. The other important thing is the k variables are ordered, and moreover the k variables are mutually independent, orthogonal in mathematical sense. So we got orthogonal, so we can do most of the things. The other nonlinear approach, instead of linear combination, we are having a lot of nonlinear combinations also, where the partial least square method, and there are so many other methods are there. They are linear transformation. Then selection method, we are having feature selection. We are having other, here only most of the machine learning approaches comes here to select the best subset of variables. Okay. Now the problem setting is something like what we are trying to do. We are given a set of data which belongs to XY. Yeah, we have to find the learner such that the classification problem you want to say either do a classification is either -1 or +1 or equal to 0 to 1 also. And the regression problem is a real valued function from the interval 0 to 1 or also. So what we are trying to do is, yeah, if we are taking the function, so for each of the case, there are n attributes, the n variables, correct? What we call the features, variables, or is going to be attributes. There are different persons, they are having different things. Don't bother. It is only a notation. So in for put it mathematically, in the selection, what we are doing is we are having these variables. There are n variables. Out of it, using a selection method, I am using subset of best subset of variables, some m variables that is going to be represent the whole thing from a bigger space, just a various of space. Whereas in transformation, what we are trying to do is from the fn function, we are going to have some other function, the latent variable concept. This is the main difference. Where the original variables is the variables are there in the selection, it is easy to interpret in terms of the original variables. Where in the transformation methods, we don't have any direct interpretation. You have to look for the coefficient and indirectly you have to pick the weights based on certain threshold value. We'll interpret it. We'll come to that later. So the optimum feature subset terms are classified from etc. In other words, this way already said. We'll go for this one. So there are certain criteria for optimality. You are setting a subset of variables. How best you can able to test optimality? There are methods by which you can able to test optimality, and because whether the subset which was selected is optimum subset or not. Now, what are the common feature extraction method which you said? No, principal component analysis. Already told you there is a linear transformation method. Partial least square is actually it is also linear, but only thing is each variable can have because you are having y is equal to let us say f of aixi, then y is assumed to have a random with a certain distribution where x's are supposed to be fixed, that is they can be measured exactly and they are independent, they are additive. Here PLS, your x's also can be random, that means each can have their own function. That is the thing. And one of the important things they are using in the extraction is the discrete Fourier transformation, because you know all of you Fourier transformation is real here, but most of the studies say that the discrete Fourier transformation performs better than the Fourier transforms. Of course, there are method what you call the stepwise method. There are forward, backward, stepwise. What you are trying to do is introduce all the variables in the equation, try to eliminate one by one which are unimportant and stop when further removal is not possible. What you call the backward. The forward is going to be first to take the most important variable based on certain criteria like correlation or something like that. Then try to go on adding until the further addition is need not because the model improvement in terms of some measures like R square is not improving. So this is extraction. Here only the concept comes in selection. Whenever you want to get a subset of the variables, first thing is the genetic algorithm. Remember, genetic algorithm is what you call universal optimization technique. It is based on hardcore biology, and there are three operators. One you call the selection. What you call selection is based on most of you know. You need not know biology, but at least 10th standard we studied biology. So it is based on Darwin's theory. Darwin's theory says the survival of the fittest. That means persons with higher fitness will contribute more to the next generation than the person with lower fitness, correct? So this is the thing. So next one is what you call the recombination. We are getting one copy from father, one copy from mother, and the child will be there. And the next one is mutation, changing one gene to another, 0 to 1 or 1 to this one. So these three operators, in other words, persons with higher fitness, only persons with higher fitness will come to the next generation and lower fitness will be eliminated for the population. So in algorithm, what we are trying to do is, in all our classical optimization technique, we try to go from one solution to another, one at a time, even linear program, one point to another point, correct? But here it's not like that. You can generate several solutions simultaneously, try to optimize everything. Then one stage will come where all lower solutions will be filtered. You will get only the best solution available in the thing. The best solution may be unique or may not be unique. So that is genetic algorithm. It is almost a universal optimization technique, a very powerful algorithm, and this technique is based on the probability concept. The second fuzzy logic, all mathematics, you know, because the information, whenever you're getting vague or incomplete observation or what you call uncertain information, so we are going to fuzzy. And most of the information in real life are only fuzzy. Let's say there is a good boy, he's a nice, he's beautiful, this color, everything is going fuzzy. And most of the faculty members are very good in fuzzy logic. So, and next one, the most important thing, you know, particularly for selection, best selection method in the future, the rough set plays a vital role. That is order of the day. So rough sets is the most important aspect in reducing the dimension, particularly when having best subset selection. Where I got 2000 genes, I want to get the best subset by eliminating all other things. So rough sets operate in both the ways. It reduces the dimension of the variables as well as the number of cases also. Whenever there is going to be redundancy where the classification is not going to help, it is going to relieve it. A very powerful algorithm. Of course, from rough sets we have moved to soft sets, we have moved to inner sets. We are having, there are so many other things have come in the last 5 years. There are a lot of new. In other words, most of the classical methods which are studied in hardcore mathematics that has been borrowed and it has been. Of course, we are having the Einstein optimization, then particle swarm intelligence. All the things are based on what you call the hardcore biology concepts. Here we are talking only these three aspects. Just we'll try to. So how it has been done, correct? So what actually you are doing? So mathematically, what we are doing in the concept of learning is, so whenever you want to have, it is a function from a d-dimensional space to -1 + 1 is the classification of binary. -1 to +1, correct? Is -1 or +1. Where in a multi-class classification, it could be 1, 2, 3, 4. So disease or non-disease, express or not express. Is pass or fail. That is going to be this one. And the other one. So whenever you're having more than 2 classes, still we can have the finite response, which is still qualitative. But a regression problem, what you're trying to do is, here we are going to have, it is a map from 3 dimension to the rail line, correct? So that all of you know, this is a mathematical, that's what you're going to do. And one of the major problems, you know, so what we are going to do is, a simple example, suppose we are having the opposite vertex of a square belongs to one group. How to develop a classifier, and most of you might have faced the problem, you might have read that, you might have taught to the students how to do this one. There is no way of, it is a 2-dimensional plane where we are having the opposite values of the square or the rectangular belong to one group. How to, so what we are going to do is, this is something like this, x is equal to -1 if x1 and x2 are 0, or x1 x2 are 1. Whereas it is -1 is going to be +1, -1 +1 classification. So what you can do is the transformation. So you are going to make the transformation as 5x1, x2, x1, x2, this one with the weight of -1, you can be able to put it. So graphically, similarly, we are going to have all the points inside the circle, all the points outside the circle. You can use the transformation sin of x1 square x2 -1 to get, if you use the transformation, then all the points inside the circle will be below, all the points outside the circle. In other words, still mathematics gives certain methods of transformation to have one plane to other, correct? The higher dimension to lower dimension, we can able to do it. And the linearization of circle, this is the function we are having. So x1, x2, x1, x2, x1 square, etc. with weights 0, 0, -1 and minus. So the same thing we can able to do via linear discriminant analysis. That is one of the techniques that has been there. The only thing is, you know, this kind of transformations are available from 2 dimensions to 3 dimensions, up to 3 dimensions we are able to do it. Beyond 3 dimensions, we cannot be able to visualize it, correct? It is very difficult. So here only the consequence, what you are trying to do is, how best this can be done. Here machine learning approaches are coming in handy to make, so most of the machine learning algorithm does only one thing. Things which are in the lower dimension are mapped to a higher dimension using a transformation, then use hyperplanes to separate them. That's the concept. So whenever things are there in the 2 dimensions which are unable to separate in the previous case, so map it to a 3 dimension, then it is something like this. pulling one corner of the square to a third dimension, then use hyperplane so that both the red points will be above and both the blue points will be there. So that is the basic idea for most of the machine learning approaches. Okay. So with this background, now we'll go for the main topic, machine learning approach. What are the machine learning approaches? So we start with the oldest and from 1940s. The oldest one is artificial neural network. It is an attempt to model the function of the brain. How the brain, so it is an attempt, still it is going on. It is one of the powerful tools mathematically how to model the function of the partially capture the computational sense of the brain. That's what we're trying to do. A very powerful technique where most of the classical models, where mathematics or statistics, these can be obtained as a particular case of a neural network. That's why still it is popular. And second one is the support vector machines. A very powerful tool. So the learning problem has been converted to what we call the optimization problem. To be more specific, it is constant optimization problem with Lagrangian multipliers. We borrow the concept from Hilbert space, those were analysis. So this concept. So in other words, wherever the neural network is there, a learning algorithm which is very slow, the optimization, any optimization problem is more efficient. The results are more reliable. So the support vector mission from 1995, 93, 94, then 95 become very popular. Genetic algorithm already we talked this one. Then decision tree. There are about 40 decision trees where starting from CAR to C4.5, ID3, ID4, ID5, C5. Then out of these, most of the tree structure will be there where decision analysis, all of you know, the tree structure is there. Fuzzy logic already we said, to those who are new, fuzzy, so we used to have only one thing. Suppose the data is going to be, your weight of your age of a person is 30 years and weight is going to be, let us say, some 80 kgs and height is going to be 150 centimeters. We got very good methods to model this data. On the other hand, a young boy, average height, overweight. So this kind of information is commonly available, particularly most of the times. Then how best you can able to do it. So what you call the linguistic thing, how to convert these kind of vague information or fuzzy information into numbers. That's what. So fuzzy logic, all of you know, it got its own grammar. And most of our day-to-day decisions we are making only use the fuzzy logic, even though we are not explicitly telling that one. Rough set already said it is very one of the most powerful tool, and we are going to see some of the results here. Then hidden Markov model. Most of you know about Markov model, one of the classical models because whoever studying about stochastic process, they start only with the Markov model. Then so what is hidden Markov model? In a conventional Markov model, you are having observed state, you are having hidden state, there is a one-to-one correspondence. So any hidden state will produce only one unique signal. Given the signal, we can able to identify what is the underlying state. But in hidden Markov model, two or more underlying states could produce the same signal. Same, given the signal, is very difficult to identify what is the underlying what you call hidden state. So that is the main thing. And remember, most of the about 70% of the algorithms, what you call the optimization algorithms, are based on hidden Markov model, because most of them, given the signal, we don't know what is the underlying state. That is the real situation. So it's a very powerful tool, and most powerful tool. We got very good theory, and we are having three types of hidden Markov models, where we are having the learning, the optimization, and very powerful tool. The next one is Markov chain Monte Carlo, and most of you know, it is. I said no, the idea. Suppose I got 2000 parameters for an equation there I fitted. I want to solve it. Which analytically I cannot able to solve it. Even data I want to fit it, there is no data for that one. So how to get some estimate for the parameter? So Markov chain Monte Carlo is otherwise called as model liberation moment. That is what we are trying in Markov chain Monte Carlo. Whatever be the function, whether parameters are going to be 200 or 2000 or 20,000. So take construct a Markov chain for each one of the parameters. So allow it for a long time so that it converges, because the interdependency between, because Markov chain is semi-dependent, correct? The previous observation, current observation depends on the previous observation. So if you allow it for a long time, the interdependence is removed, and you are getting what you call the stationary distribution of the ergodic limit. Then use the conventional Monte Carlo simulation method to characterize any complex distribution. In that way, wherever the number of parameters, whatever may be there, we can able to get an approximate solution for this one. It is a very powerful tool, And when dealing with this kind of high dimensional databases, so one simple way is construct a Markov chain, allow it for a long time, then you will get the ergodic limit for each of the parameter. Then try to use the conventional Monte Carlo simulation method and to characterize the distribution, correct? Of cellular automata, because this is one of the oldest technique, but still popular. And those who study cellular automata, because normally Christian College and other groups, MCC, they all have the cellular automata, even from Rani's Rodmani period. Here, and what is this one? In real sense, what we are trying to do is, in biology sense, if a cell has to survive, minimum 50% of the surrounding cell has to survive. So that concept has been borrowed to make this one. Then all the things are borrowed to solve the problem, correct? And most of the times, a single algorithm may not be sufficient. So what we are trying to do is hybrid approaches. For example, if suppose you want to do a neural network fitting, first what you have to do is use genetic algorithm to take the best subset of variables, because you are having a large number of variables. So how to choose the best subset? Genetic algorithm is one way. So I will run the genetic algorithm, then use the subset variables to put as input for the neural network. So there are two things. One is first the data is there, specify the output, so that there will be a lot of overlaps will be there within this one, which can be able to classification will be better, or even you can use rough sets, or then you fuzzy whenever data set is we specify it, then give us input for the neural network. But neuro fuzzy and fuzzy neuro are the two different aspects that are used in different situations that you have to remember. And one of the major thing, for dealing with any high dimensional database, particularly modeling, is the front end will have a neural network and the back end will have a Markov model, and you can able to any complex situation. Suppose I want to have one of the simple example is a protein structure. I want to predict it. You take one cell from any of us. It contains a string of ACGT, the 4 nucleotides. So what is the length of this is going to be 3.2 billion. That's the length for, if you take one cell from any of us, you sequence it, the length is going to be this one. That's the length of this one. Then this can be given. So neural network can be used as an input, then back end Markov model. You want to identify which are the coding or non-coding reasons, or which are the gene part, which are non-gene part. We can be able to do it. Similarly, we're having other concepts, In other words, most of the time, a single algorithm may not be sufficient. We'll have 2 or more algorithms, correct? That we'll see later with 1 or 2 examples. Now, the data representation normally is going to be logical, or is going to be probabilistic, or is going to be mixed. 3 types. So whenever you have a logical thing, the decision tree is the logic grammar there, because it is going to be symbolic, and symbolic notation. So logical decision tree is one of the important concepts that has been used. Probabilistic, yes, neural network, Markov model, SVMs, etc. Where we are having the mathematical function, but not easy to understand because very complex functions, and because the functions of the number of parameters are going to be more, and the concept involved, the underlying concepts are very hard. And next one is a mixed thing, because part will be logical, part will be probabilistic, where having Bayesian networks, cross-equalizing, etc. And these are the 3 things. So your data type will be always this one. Normally we'll have, because it's a matrix form, data matrix. The only thing is, our here in conventional matrix, so we are having the conventionally we have the columns always represent the variables, the rows always represent the cases, correct? The equation. That is the conventional thing. But most of the times in bioinformatics and other field, because the numbers are going to be 20,000, 30,000, it cannot be represented. So you will have the row wise, you will have the genes, and column wise, you will have the sample. That you have to remember. Whenever you are having using conventional package, you have to remember that you have to make a transformation before using it. Otherwise, you will treat the sample values as variables, and the variables are the genes are treated as samples. That's going to be there. So in any the real world situation, particularly when you're dealing with high dimensional databases, the number of variables are more. So that is one thing is over. Now to give some idea, linear discriminant analysis is one of the classification technique, very powerful. Suppose we're having 3 groups are there. If you're constructing linear perform actually graphically what you're trying to do, you are drawing the line to separate the 3 groups. These are the things. On the other hand, you are having a decision tree classifier, you are trying rectangles to make them. This is going to be rectangles. Whenever in Gaussian mixture, we are going to have the circle indicated so that the always will be there. Whereas the kernel method, able to tilt, you can able to you can see it just like any spline functions, but they're not spline because splines are going to be non-parametric in nature. Here are going to have aqua parameter. We can able to get it. So this is the thing. So this was graphically the methods are doing in classification. Okay. Then this will come to the machine learning, broadly classified into three categories. One is supervised. Supervised means you are having a dependent variable, you are having independent variable. In a classical sense, any linear model, you suppose you said y is a function of y is equal to sigma a xi, that is a supervised because you want to predict y as a function of xi. But whereas unsupervised, there is no xy relationship. A group of things are there, you want to group them based on certain similarity or dissimilarity measure. The reinforcement is going to be a combination of both supervised and unsupervised. That is the, most of the times you will be restricting only to the supervised and unsupervised. And there is another thing, because whenever you are having, there is a lot of things about a neural network, then we are having artificial intelligence, then we are having pattern recognition. So pattern recognition, what do you call it? The neural networks lies between the AI and the pattern recognition. It is a technique, this one. So the pattern recognition is going to be based on most of the statistical models, and it is going to be decision trees, and neural network is one of the important things. The nearest neighborhood, then support vector machines, everything, correct? So most of the AI techniques can be used for pattern recognition also. So with this introduction, now we'll come to the first and of course one of the earliest attempted to model the high dimensional databases, particularly when you are having a number of variables are going to be number of this one. And so what you are so neural network. So it is biologically inspired. It attempts to model the capabilities of human brain. So it is generalized. In other words, given based on the examples, it try to learn and try to store this, correct? So in statistical perspective, it is for prediction and classification. We are seeing in the computer language, you are using the word prediction for continuous variables and classification for discrete. That is the thing, correct? Your outcome variable you are going to predict, then you continuous the prediction. So to define neural network in a very formal way, so artificial neural networks are massively parallel. So brain is supposed to have parallel architecture because we are having layers. The layer, one layer, we are having one layer, so one unit to next it will connect, but between layers there is no connection. So that's why it is going to be there. It is an adaptive networks. It is not ADOPT, it is AD adaptation. Adaptation based on what they call the Darwin's theory. Adaptation of simple nonlinear computing elements called neurons, which are intended to abstract and model some of the functionalities of the human nervous system. Only some of the functionalities. Any number of AI techniques cannot be able to capture the brain function, correct? Because there has been evolved for millions of years. Any number of, even if we are capturing 1 or 2% of the brain power, that is what they call very, very high. So some of the function of modern brain in an attempt to partially capture some of its computation sets. Only some of this one, correct? That is the idea. Now, we say no. It is still we are having why the neural network. There are so many methods are there. Why neural network so popular? See, the generalized linear model in statistics that contains a rich class of models, where so that can be obtained as a particular case of feed-forward neural network with no hidden layer. Correct? That is going to be there as well. Whereas feed-forward neural network with one hidden layer is nothing but the projection circuit regression. That is the highest level of regression, the n-dimensional regression. Almost all regressions which are considered in the world can be obtained as a particular case. One more thing, the feed-forward neural network with one hidden layer. So any complex function, you take it, about 95% of complex functions in the real world can be approximated using a neural network with one hidden layer. Only 5% you may have this one hidden layer, correct? Similarly, most of the high-level mathematical statistical techniques can be obtained as a particular case of neural network. That's why still we are using a neural network, very powerful. And of course, to give some idea, convention, everybody knows about regression. So whatever there are terminology changes, because whenever the computer scientists, whatever you are having, they will use their own terminology, because since we are borrowing the concept from the AI based things, and some of the terms, the input is not the independent variable, what you call the output is the dependent variable, the weights are not the regression coefficients, the bias weight are without is going to be intercept, what you call error they call the residual, and learning is nothing but estimation, and of course ML is nothing but a cross entropy. These are some of the terminologies. Now this is a biological neuron, these are called axons, this is the dendrites, then this is the cell body where and then from this it is going to communicate to the next one, correct? Whenever it will be processed, whenever it ends certain threshold, it will communicate it. How to model this one earliest attempt? So biological neural network learn by adjusting a chemical connection between the neurons. Whereas the neural network, these are the what you call the dendrites. So these are our inputs, and these are the weights we are going to have it. Then we are going to have the inner product. Then compare the inner product. Then try to apply certain transformation functions to make the value, whatever value you are having, to be the value from 0 to 1. Then fix a threshold value. Default option is 0.5. 0.5 more, you communicate to the next one. Less than 0.5, you won't communicate. Correct? That's the thing. It is only inner product. Now I said no. This kind, any neural network is all of you know there is one concept. This is a neural network where I'm age, gender, sorry, these are the weights, and they are going to apply a function. Sigma, this is only the inner product. Then apply certain transformations. Then whenever the value is there, then we are going to communicate here the transform value. Then 4 2, then the weights are going to be there once again. Then ultimately is a 0 1 function, a S function, is logistic function used. Above 0.5 means, so it is going to be called as a case, or less than is going to be that. In other words, any neural network, you will have the input, we are having the hidden layer, you are have corresponding weights and different variables. The hidden layer may not be unique, it might be more than one hidden layer, whereas similarly the number of hidden nodes, these are called the nodes, you can have more than one node depending on the complexity. So everything, so you are giving a case here, the model should predict a case. Everything is matrix multiplication, nothing other than that. The weights will change. Yeah, if a case has been predicted as a case, then we leave it. Otherwise, what you are going to, if a case is not there, then try to correct the error, go back and change the weights. Still is there, change the weights until a case is predicted as a case. Similarly, a non-case is now predicted as non-case. That means the weights will be, after sufficient number of cases, the weights will become stable. The weights become stable, that the model has been learned. Any new cases coming, unknown cases coming, you can able to give to the network. It can able to predict whether it's a case or with control with 99% or 98% certainty, correct? That's what. Now, the neural network is not new to us, because most of logistic model where have the variables, each of the variable is connected to y here, because the logistic regression outcome will be 0 or 1. In a conventional regression, y is continuous. Here is going to be y is binary, 0 or 1 means we are using. So in other words, the logistic regression, the neural network is nothing but the combination of a lot of logistic model. Each node, hidden node with the input layer, we can say it is one neural network. So this one similarly, all that. In other words, it is a generalization of combination of logistic regression network, because ultimately the regression logistic also does the same thing in the y. It is going to be 0 or 1 for this one. So binary logistic regression, correct? So that is the one thing. And fine, okay. Now, having said this one, this is a neural network. Already we know it is going to be hidden layer. You normally, conventionally, I said about 90 to 95% of the times one hidden layer is more than sufficient for most of real world problems. But the number of nodes in each hidden layer vary. But certain complicated data sites where particularly high dimension data, we may need more than one hidden layer. So how it has been done? It is by trial and error, because based on the predictions. The next neural network is what we call the RBA, radial basis function network, a very powerful network. Here, a perceptron network can have the number of hidden layers are arbitrary and the number of nodes are arbitrary. If the data is very complex, we have to increase the nodes and we have to increase the layers also. But whereas here, irrespective of the complexity of the data, the radial basis, mathematically we know radial basis functions are very powerful. And what we are going to do is, irrespective of complexity of the data, we will have only one hidden layer, and most of the kernel functions are used here. And because this is a Gaussian kernel, by looking at the shape itself, we can able to do it. There are so what I do is just will say one example. We have taken suppose you want to classify some two strains. One is this is a very powerful disease strain, just like COVID. It is called a CDC Atlanta, a TB powerful TB strain. This is a control strain. The data is available freely. It is going to be big database. Then we fit a neural network model. So MLP. Then we are having these are the parameter estimates for the because of the model. We are having the weights. Wherever we are having back, the weights will be high. Then, so this is RBMS network for the same data, and these are corresponding weights. So just to summarize, what you are having is, so normally any machine learning algorithm, because we have to validate the model, what you have to do is, so in conventional, in a regression problem, we fit a model, suppose 10 variables, 100 cases are, fit a model, you take R square, then R square gives a measure, what is the level of, what is the, how much it has explained to different variable y in terms of this one. Suppose you are having R is 9, then square it, you will get 81% of variation y is explained by the xi is. That's what we are going to say. But here, no such measure is possible. So all measuring approach is one thing. Whenever a data is there, you divide the data into two things. What you call the training data set, about let us say about 70 or 80% of data divided for training, building the model. Remaining 20% or 30% of data is used to what it test the model. How good the model is to predict, because we know what is the outcome. Because each of the variables we are having, the outcome is known. How correctly it is predicted, correct? So that's what it does. And in that way, the training period we can able to 97, 96. For the test data, we get about 95%. Anything above 90, 95 is a good prediction. And that's what we are going to do. Then the other important thing, I'll just qualitatively inform, one of the major problem I dimension is, I said, no, take one cell from us and you're able to, what you call, sequence it. It is a string consists of 4 letters, ACGT. Most of the places, the ACGT follow a random order. Only those portions, because only it is something like this, you take a railway track, you are having 2 lines are going. Then you take the genome as the what you call the DNA sequence and the railway track. We are getting 1 copy from father, 1 copy from mother, and we are having stations in between. Stations are like genes, correct? So it will be only certain portion of the less than 3% of the sequence codes for the gene. How to identify them? Then that is one problem. Other one is given the genes, then they encode for proteins. The proteins are going to be the functional unit, correct? Genes are fixed, but proteins are the functional unit. So given this one, how to pick this, given a string, you want to identify which are the portions. Among the foreign proteins, there are 3 types. One is called the alpha helix, next one is beta sheets, and the next one is going to be what they call loops and coils. Yeah, 3-way classification. There are a lot of algorithms. The earliest algorithm is going to be Cho-Passman algorithm, which is about 50%. Now, the level of model, which is based on information theory, we got 70 to 75%, and even the latest algorithm. So we tried out the other algorithm based on the feature extraction method. So the data is available. It is going to be the protein databases. These are available in the environment. What we did from the database, just to, this is the database available, correct? This is the database from which you have to identify this one. So just to convert this one, it's a small programming. Just you can have Python or R. It's going to be Perl or BioPerl, whatever programming. Just convert each one because and you will get the what you call. I got about 7 features. These are like our principal component latent variables. So all we are having latent frequency alpha, beta, and others. Propensity score alpha, beta, and others. Evolutionary score that is going to be the rich amino. Then 6 gram what you call code. We are having the 20 amino acids. Totally we are having. If we take there are 4 letters nucleotide. If taking 3 at a time, we will get 1 amino acid. That's the concept. That means you are having 3 positions. Each position can be filled with any one of the 4 letters. So 4 into 4 into 4, 60 per combination. That is going to be a domain, but they converge into only 20 amino acid plus 1 soft codon. So that means That is the biology. It's only 8th standard, 9th standard biology. So what you are having, this part we can able to do it, convert this one to this one, then use a neural network where we can able to say our method can able to get about 80-90% correct accuracy, correct prediction of this one, the three-way classification of the protein. Whereas the conventional, the so-called method which is based on information theory, resulted only 72. That is, in other words, the neural network model can be incorporated and it can be advanced by making transformation. We can able to do it. Still, 90%, I think we can improve 95% to making certain things, correct? The other one is, there is another way, the neural self-organizing map is another neural network which is used for clustering. So, but this is a what you call normal individual. These are the images of a normal individual. These are the images of a patient with what you call benign cancer. That is, then these are the malignant actual cancers. These images can be and one of the important thing is, which cannot be done otherwise, we can be able to quantify the contribution made by each of the variables to the overall classification. We can suppose radius is one variable, texture is one, just if we taken only something, we can be able to quantify it. Neural network is another self-organizing map is another neural network. In other words, everything we can able to, there is one method called compound plane attributes. We can able to quantify it. Remember, the color, only 3 colors will be there, red, green and blue, because those are basic colors. And based on this one, we can able to do it. So that is a neural. And neural network can be generalized in so many ways to accommodate what you call other complications. For example, Bayesian network. Bayesian, all of you know, you are having the parameter constant in classical statistics. You assume the parameter also got one distribution, then become a Bayesian. The conventional neural network, we said the network, these hidden layer nodes are constant because you are in the inner product, then you are using certain transformation. Instead of that, you assume certain distribution for each of this one, become a Bayesian neural network. Very powerful network, and it is widely used, one of thing. And how to generalize this one? There are a lot of methods. You are having only one hidden layer, then we are having other things, hidden units. We can be able to do it. It is another important development in neural network. The next one is the conventional neural network uses this kind of algorithms. So how they function is nothing but the inner product, and where the weights and other things are added here. Whereas in the vertical Bayesian neural network, we are having the exponential function with this one. So these are technicalities how to construct a neural network, and these are the learning algorithms. The next one is the convolution neural network. Here, this is the order of the day. What you are having is so previously what we said, if you got an image, I have to use certain selection method or certain transformation method, what you call extraction method, to extract the properties or the variables from a huge volume of data. Then they have to reduce the dimension, give it. But the problem here, what you are, it's a network. Suppose you are having image, the image itself is given as an input in this one. Then the neural network consists of hundreds of layers. Remember, hundreds of layers. The initial layers, they will each layer try to extract 1 or 2 features of the image or whatever material you are putting inside. Then after sufficient extraction, the second part is the neural network. This part is the neural network, correct? It does this. Now you can be able to see this is the convolution neural network, or the most what you call predominant network technology that has been applied past 5 years. Then we will come to the support vector machines. I said support vector, already talked about this one, is a very powerful tool and very, because it is an optimization problem. It addresses some of the limitations of neural network. Wherever neural network can be used and the support vector machine replaces it. And since it is an optimization problem, particularly Lagrangian multipliers and constraint optimization, it as a most mathematically is a more powerful technique. And what we are trying to do is, the way it's called a support vectors. Suppose these are the 2 groups, I can classify in so many ways. So this is the maximum classification. If the line is there, then the points which are lying here on the boundary of the maximum classification length, they are called the vectors, support vectors. And why it's called a machine? Because already most of the time the names are very funny in times, because Tuki earlier said no, jackknife is one technique where one of the technique leave one at a time, how to get the resampling plan. Then when Efron said bootstrapping one technique, they asked why you are calling it bootstrap. He said no, he called jackknife, so I am coming to it. That's the way the names have been given. Here the machine, he said no, because it is support vectors, and he added the machine by Wapnick. So then, so this is the, in other words, what we are trying to do is the support vector. A n-dimensional space has been projected to a 2-dimensional space, so that how it can be then correct. We're going to have it. Okay, we'll cover. It is so the same problem which you are consider. So you are having a polar dimension. Apply the from 2-dimensional map to 3-dimensional. Use hyperplane to separate them. So higher dimension is easy to separate. So that's what the support vector machine does. And these are the kernels that have been used, particularly the Gaussian kernel, the radial basis, sigmoid function. About the tan is sigmoid. Sigmoid is the S type of curve, no, because it is the most common thing. Whenever you are in the curve, is going to be more steep. Classification will be better. Of course, tan HX, the hyperbolic, hyperbolic function, which is tan H kernel, and we are having another 5 kernels, which are again trigonometric functions. We can able to use it. So the covering theorem, what it says means a complex pattern classification problem case in high dimension non-linearly is more likely to be linearly separable in a lower dimensional space. So this is the support vector missions. Well, I said no. We borrow the concept only from Hilbert space analysis, correct? This is called the Mess's theorem. So this theorem says SVM can be embedded into a framework of kernel-induced Hilbert space. They embedded in this input X into a what you call dimension Hilbert space H and the so-called. So the concept is very simple. So what you are doing is to tell non-mathematically. Suppose I want to get the inner product of phi of X into phi of Y. Correct? We know how to get it. Suppose I want up to 2-3 dimensions. We already seen example. I want to get the inner product phi of X and phi of Y without specifying phi explicitly. Correct? Without phi of X into phi of Y, without explicitly specifying what is phi. There only the concept, we borrow the concept from Hilbert space. So that's what the Hilbert space are. That's what support vector means. So get the inner product. Ultimately, all your network, everything will be inner product. Then whenever I am multiplying 2 inner products, without explicitly specifying what is the function of phi, we can able to get it. That is the idea. So that is about kernel trick. They used to call it as kernel trick. Just a minute. Hello. Hello. So the next one, what is the power of this kernel function, support vector mission? This is a 3-way classification. In other words, we can draw a boundary. This is a MATLAB diagram. You are having, suppose using. We can able to, it's more flexible. It is parametric in nature, but still it behaves better than a spline function which are non-parametric in nature. So that's the idea. And mathematically, what we are trying to do in a multi-layer perceptron, we are having the classification DA minus the function is going to closeness in data. So we are using this function. Where radial basis function regulation, we are having the penalty parameter here for smoothing data. Where support vector mission, this is the penalty function, correct? Phi of X. Okay. And so the other important thing is, some of these lists we are having. In a conventional, you go for any physics lab, any person will be coming in spectroscopy. What you call FTIR means Fourier transformed infrared spectroscopy. So they are used to diagnose, and the sample is given based on this one is a diabetic or non-diabetic. What they are trying to do is, they read from 700 to 4,000. These are the number of things. So cases and non-cases, based on this one, they will classify. This is the magnified. So these are the cases, controls we can able to get it. And so this will come. So what they are going is, now most of the time what they used to do, they take only the peaks and they will compare, because they will have 10 cancer, 10 diabetic, 10 non-diabetic, most of the time for a PhD work or a paper, or at the most 20. Then they take the peaks, you apply some t-test between the results and do it. But nobody is taking the whole spectrum as this one. We can able to do it, then use principal component, where the 3 components can able to capture about 99% of the information. So 3 components can be used to make a classification, and we can have a diagram also for this one. cluster diagram. Ultimately, we are more interested in this one. A conventional logistic function will give you classification. Statistic will give you 80%. For the same data, multi-layer per subplan 82. Our radial basis function gives 90%. SVM result higher than this one. Similarly, for another chemical data also we are having this one. In other words, the support vector compared to any of the classical methods, the neural network models perform better. Compared to neural network model, support vector is the most powerful tool. Then genetic algorithm, most of you know, because yes, any doubt? Anybody?
No, sir, you can continue.
Okay. Now, the genetic algorithm, naturally we are having the initial population, most of them are doing these problems because a parent selection, genetic operation, the new population repeats the step until you come out is any. So whether further things are not there or you can able to stop it. So in fact, using simply a genetic algorithm can be used to solve the problem y is equal to ax square plus bx plus c also. Correct? You can do it. But we won't do that one because we are having other simple methods. So genetic algorithm, when the number of solutions are more, you are generating a lot of solutions simultaneously. You are optimizing all the solutions and filtering at every stage. Ultimately, you will get a group of solutions which cannot be further diminished. That is the candidate. A very powerful method, particularly for variable selection. It's a very powerful tool. I already told you. To give some idea about this one, what is the general global search methods? Genetic algorithm is used for optimize the network topology neural network. In other words, you can able to say the error is going to be after back propagation, it will go up to this is certainty it comes, correct? Where the generalized neural network, it will go something like this. This is the genetic algorithm error, correct? This is going to be there. So the computational cost will be very high for back propagation. So genetic algorithm in between. So the error rate also you can able to see the y-axis. So genetic algorithm performs better. This is generalized neural network, correct? ANN or cost. Then fuzzy, all of you know in classical sense. So for series, an element belong to a set or not belong to a set. Where classical set theory, we say that whether X belongs to the set or does not belong to the set, correct? Either or. But in fuzzy logic, all of you know it is a partial membership. It can belong to the set or not belong to the set. So most of the time we used to give the example of our Ardhanarishwara. So a gender means male or female. Ardhanarishwara is male or female. So if you look from the right side, you will say it's male. From the left side, it will be female. It is male and female and concept, correct? So that is going to be there. Whereas rough set theory expresses the boundaries in partial and not partial membership. They are having. So fuzzy sets are concerned with vagueness, whereas rough sets are under the indisability. So these are some of the things. I think these things we can give all of most of you know about this one. The rough set theory, just on some slides, we are not discussing theory, only to say that it's a way, the vague concept is replaced by a pair of precise concept, what we call the lower and upper approximation. So whenever a data is given, you are having so the concept is something like this. In a classical set theory, the sample size bound is fixed, and the sets whatever you are given, they are mutually exclusive, no interaction between them. So for fuzzy logic, the boundary is fixed, but the sets which they are not mutually exclusive, they are overlapping. That is going to be. But rough set theory, even the boundary is not fixed. The sample's boundary is not fixed. So what we are trying to do is, we are going to put one upper bound and lower bound above the boundary. Then we say that when all the elements below the lower bound definitely belong to the set, above the upper bound does not belong to the set, and between the upper and lower bound, the elements possibly they belong to the set. That is the idea. That's why it is called rough set theory. So this is something like this. Suppose we are having, this is, let us say, inner boundary, this is outer boundary. So these elements are outside the boundary, they are not belong to the set. These are belong to the set, whereas these elements external 3 possibly, because this is going to be there. So this is no area, this is definitely area, this is yes or no area. So very powerful tool given this one, because where it is there, suppose you are having a set of data, you 2 persons are having the same values, height, weight, age, and other everything. One person is responding, other person is not responding. That means whatever features we are considering, it is unable to distinguish or whatever discriminate between the two things. That is, you can ignore that variables. That's why that's how it minimizes most of the dimensions. Then why I have shown this one is the neural. We saw what we call various types of neural network. The rough neural network is the most powerful. For each of the what you call hidden layer, what you are getting, we can generalize it by using what we call the rough concept. Instead of having the neuron is not fixed because you are having after all it contains inner product, then try to have certain transformation. Instead of that, you have make it as a rough neuron that is very powerful. In fact, it performs better than most of the other methods. The rough neural network, just again, what are the things and other techniques? Just we come to the first thing. So what you are having is, I said the data already we have shown 60 variables and variables are this one. So just it has been done. So you are using a genetic algorithm. The number of variables are how many? It is going to be 7,125. So by using this one genetic algorithm, selected 496 variables, shortlisted 4, and using this one, the classification accuracy is 86%. Whereas fuzzy logic, it has taken slightly lesser, 321 variables as the best subset variables. I are having 90. Where rough set, it has 245 and classification accuracy is 92%. But fuzzy and rough put together, it gives almost 98%. So the hybrid algorithm, otherwise, even the high dimensional data, a classification problem like this, where the problem otherwise cannot be addressed, 7,120 and 60 cases are in mathematics. 7,000 variables with 60 equations, correct? That's what we're trying to do. So there will be the subset evaluation. These are the order because naturally we are using fuzzy and the number of subset evaluated will be very high, and 98.4 is the best subset selection, correct? It is going to be there. So in other words, we see the rough set based fuzzy method gives better results than other thing because it gives another 4 or 5%. So here is a way by which you can able to analyze the high dimensional database. We can build a model, whatever model we are having, using machine learning approaches. The other one, the image data, I will take this one, where 123 cases, 2,500 variables. So we are going to have this one. Again, the genetic algorithm, it takes about, because 2,500, of course, the reduction is very only about less than 50%. So 1,014. And the what you call accuracy is about 81%. Fuzzy is going to be 86%. Rough set, here the neural network, 734, 80, 90%. So rough neural network, which I have shown earlier, the rough neural network says what you call 412 variables where single accuracy is 460. In other words, the combined algorithm, because most of them are non-linear in nature, so it is going to take some of the things and difference. So with the 412 selected variables out of 2,500, we can able to, so instead of using this 2,500 variables, it is enough to use 412 of this one is selected using the rough neural network concept. We are getting 96% accuracy. So that is the performance. In other words, the world, just to give some 2 examples from our publication to say that how the what you call machine learning based approaches improve the classification error, correct? It is going to be there. Most of the times the hybrid algorithms always perform better. Then other important aspect what you are trying to do is, so far we said full data set, correct? But whenever you are having incomplete data, suppose you are having 100 observations where 80 observations are full and 80 observations are full, whereas other 20 observations, you got only partial information, not missing, partial information. To give an example, suppose a patient is there, you are treating them, and you want to treat them 6 months. 3 months treatment he has taken, he has not cured, he left. Okay, he has left. So normally what you used to do, because any incomplete, you will get greater than 3 months, correct? That means even you calculate mean, you will say greater than 3. Standard deviation greater than 3 or variance greater than 3. That means most of the classical methods, even the average is not defined. We cannot do anything. But what you are in the full survival analysis is how to take the incomplete observations also into consideration. On Cox model, 1972 is one of the famous models. how the regression concept can be extended to even incomplete observations. What you call partial information, not missing observation, partial information. That's the basic cause. Now the recent improvements are whenever we are adding what do you call the dimension is going to be very less, because I have given the data where one example to where the cancer data we are having the follow-up period for 6 years, 7 years, a median period with for 1 year to 18 years, correct? This duration, and about 60% of them are censored. In some cases, 30% of them are censored in this one. So this can be the recent developments are how the basic Cox model can be extended to model the high-dimensional databases. So what you call the regularized Cox model, we are having lasso. Lasso is one of the most powerful method. That is the syncagist method. The other one is ridge. Ridge, most of you know, whenever you are running exercise or even in a simple regression problem, when xi's are highly related, the problem of multicollinearity will be there. We try to introduce certain bias to reduce the, to stabilize the variance. Then we as it, or use certain orthogonal transformations. Sorry. Certain orthogonal transformations to get rid of the interdependence, correct? So now how this can be extended to high dimension. Next one is what you call LNet Cox. It is this one. And these are the Cox boosting all of you know how Cox model can be boosted with the what you call censored or partial information. So just don't bother much about doing except to say that the lasso Cox use the weight what you call the L1 norm. All of you know, no? This is the L1 norm. Ridge Cox use the L2 norm, and elastic net Cox use the convex combination of L1 and L2. Of course, within that we are having adaptive. There are so many other methods where partially they are using the sparsity because data is there. So what it does to in the high dimension, what you are doing is suppose I got 2,000 or 10,000 variables with let us say some 200 cases. So conventionally I cannot fit the model. So what you are trying to do is fit the model. So the lasso concept, what is the penalty? What you are doing? Those variables which are important, all the betas are forced to go to 0. That means even though you are having 2,000 variables, ultimately you will have only about 20 or 25 or 30 variables. All other variables, important variables will be for the algorithm goes like this. And the other one is the ridge Cox. It also forces all the variables which are not related to the outcome variable, but it never makes the betas 0, but forces them very close to 0. That is the main difference between these two things. So lassos, this is syncagist methods, and there are various versions for this one. In other words, when you are dealing with a high dimensional database, when the number of variables are going to be there, and the further complications, we got only partial information, what you call the censored information, along with some percentage of values are full values, some percentage of partial information. How to do it? Survival analysis gives the statistical concept we are having, number of cases should be more than the number of variables there. But here the concept is high, and these are some of the recent developments. Here a lot of open problems are there. For example, we are having these weights, you know, the weights can be changed to any other thing, you will get it. The only thing you can make a comparison, you can able to derive the results where you can, is only a simple convex combination. There are so many other combinations people are trying, you can able to do it. Then adaptive logic based on genetic concept, the adaptation you can able to do it. Similarly, adaptive elastic net you can able to do it. These are some of the things. A lot of work is going on in this area. Then we are having ridge Cox, we said. Similarly, we are having LNet Cox. There are so many other methods. In other words, the finality parameters are going to be again you are lambda alpha 1, etc. This is not, again, if lambda 1, lambda 2 is equal to 1, then we say another complex combination. We are going to get it. Weights. Then boosting. Cox boosting method can be applied to fit the sparse surveil models in high dimensional database. So what you are talking about this one is not only the dimensional variables high, the outcome variables are not observed fully. I'm getting only partial information on this one. In which case, how to model them. In such of models, recently these are the development process 5 to 6 years, and lot of work is going on this area. Still, what you have done so far is going to be only about 25% of the work, another 75% on high-level modeling. If you can able to write a project, you take one of the components, you will get very good funding from any of the things. Particularly in COVID situation, you want to do this kind of things, where the data is going to be available. I take the weekly data or monthly data for COVID and you want to build a model where there is going to be incompleteness, there are going to be missing. You can able to do wonders and you can get very good. Suppose you really are interested in writing some project, getting money. So these are the core areas where you can able to do it. Where people are need of the answer, correct? They want the need of the answer, correct? And similarly, the time-dependent costs, because most of the time what you are having is, even the regression problem, we say that y as a function of x, we assume xi's are independent, mutually independent, xi's are fixed, means they are married, and the what you call the parameters are additive in nature, error is distributed normally with the zero mean and constant variance. All the assumptions are there, but xi's are fixed. But most of the times you take, for example, age. Today we are having admitting an individual where the age is going to be 30 years. After 5 years doing the analysis, still we are doing only the 30 years, correct? The 5 years is not there. Instead of that, and similarly disease status, grading of the disease on admission, it changes over a period of time. So any data will have time dependent exercise and time independent exercise. That means you have to split it separately for this one. This is one of the important things we have to do it. Most of the time we assume this also as independent variables you are doing the calculation. That's why most of the predictions go wrong. Most of the predictions go wrong. That means time dependent formulation, you have to do it. Methods are, so it has been, remember this is the extension of the time dependent covariance to a high dimension database. High dimension database. The theory is available. So these are the theories available out, because this is nothing but what you call the hazard function. Because whenever you are getting a simple, you are having the set of values, or let's say 100 values, where 80 values are full values, 20 values are partial information, you violate even the assumption of IIDs, identically and independently distributed random variables. That means density or distribution cannot be specified directly for all the variables, correct? So what we used to do is, we go an indirect method, hazard function can be specified even for the sensor that is independent of the sensoring. So once you know the hazard function, then we can able to get the density and distribution in an indirect way, because the hazard function is related to density and distribution, because hazard is defined as, after this one is a simple way, it is the density divided by 1 minus distribution. That is f of t, small f of t divided by 1 minus capital F of t, or 1 minus capital reliability, people call it a reliability R of t, and percent here we call it survival, because p greater than t greater, probability of t greater than certain t. So that is the thing, correct? Now that I said, now what are the machine learning approaches we are having? Once you know the decision trees are there, survival decision trees can be there, and Bayesian method can be extended to high dimensional machine learning approaches. So naive Bayesian and Bayesian network, these are the two important things which can be extended to the high dimensional database. What is the difference between these two? Here the naive Bayesian assumes the xi's are independent. When they are not independent, then Bayesian network performs better, correct? Similarly, neural network, all of you have seen, network support vector machine, the advanced learning, these are the recent techniques. So what we call the ensemble learning, active learning, transfer learning, multitask learning. Then these are learnings, because when you are talking machine learning, what are the learning algorithms? These are the recent development. And of course, the ensemble method is already available. Here we are talking about the extension to a high dimensional database with incomplete observations. Similarly, transfer and multitask thing are there. And random survival, these are some of the important developments that has taken place. And bagging is nothing but boost of aggregation. Boost of all of you know, whenever a data is there, one small data set where we are unable to this one, data, sparsity data, what is to do, suppose under observations are there. And instead of fitting the model for this under observation, I use the bootstrap technique. Bootstrap technique, what used to do? Try to sample the data with the replacement. Again, you create 100 data values from the same size by using what sampling with replacement. Like that, how many data sets can be constructed? We can conduct thousands of data sets. Pick the model for each of the data sets generated and average it out. That will give a better classifier or a predictor than any of the things. So that is going to be banking nothing but bootstrap aggregating nothing. That has been done for ordinary thing. Here for survival trees also this can be extended and with the high dimension, correct? That is the idea. These are the theories are associated with random forest. The whole idea of random forest is two things. One is, it won't bother about the missing values. Even the missing values are there in the random forest because it's going to take the select subset of values, randomly select n values are there. It takes some n1 values which are subset of n and try to build them repeatedly, and every time you are going to do the random forest, and lastly you are going to average it out. And similarly, the interdependence can be also easily tackled. This is a very, very powerful tool among all the algorithms. Surveil forest, we can able to do it. The support vector regression. I know our support vector mission, we talked a lot. So this can be extended to what you call them. Actually, you have to look on the last one, the penalty term, no? How we are going to, this plays a vital role. And it is nothing but in a, the problem can be just like any of the LP problem or any quadratic programming problem. You can formulate it, it can be optimized, but not like this one because the conditions are going to be highly this one. And there are methods. Similarly, how neural network can be extended to, because neural network only for full observations. If the incomplete observation, you have shown, suppose X2 is going to be partial information or any of the, what you call, the values are going to be incomplete, how to predict it. So Cox proportional hazard model can be constructed embedded into neural network to this one. In other words, the hidden layer function is not going to be a simple, what you call, sum of the transformation of the inner product. It is going to be non-linear in nature. And similarly, the deep Cox model and convolution model, because this already we said no, because there are hundreds of layers to filter the features instead of we are having, then the neural network will be constructed in the last stage. Again, here also the no longer the weight functions or the aggregate functions are linear, non-linear. These are the recent methods, ranking-based models. They are very powerful. Don't bother much. Enough you remember, there are ways by which you can able to see the models and reason models. And lastly, the active learning. The data. So given a huge volume of data, how to get the representative data from this one? Just like electing one MLA or MP from our area to represent it. There is a huge big data concept is coming where huge volume of data is there. And some of them are, remember here, going to be what you call partial information. Then how to get a representative value sampled from the data. So the active learning algorithm gives a method by which we are reducing the dimensionality, correct? Because it's going to be, the volume is going to be, because in a big data concept where both the, not only the number of variables, even the number of cases are going to be infinity, where you are unable to even download the data in your one of our conventional computer, you can do analysis. So how to take a representative data, that is the, all about active learning. Very good algorithm recently developed. But everything based on our classical mathematics, because most of the things, optimization techniques. Then what about the incomplete data, how to do it, full data, how to do it. Then we are having tasking, okay. Knowledge transfer is the other important thing. In other words, what you are going to do is, we are transferring models that accelerate data when the number of samples are that is insufficient, sparsity of data is there. How best you can able to do it based on one thing. And one of the important things is the early prediction, because that is the day. Suppose in COVID situation, somebody is reacting every day. You are seeing how to make it. A lot of models have come, everything, and ultimately you say that somebody is saying 2 months, somebody is saying 6 months, somebody this one. Now, because the trial, whenever you are having this one, you should have sufficient time to get the response and good. Now, what this one, based on the AI technique, what you are going to do, particularly the machine learning approaches. Suppose the patient has been treated for a short period, let us say instead of doing a 6-month treatment, you are given a 1-month treatment. Based on certain marker, can you able to predict at the end of 6 months the patient will respond or not respond? Whether the patient will develop disease or not disease, or the patient will be cured or not cured, or the patient is the risk of getting any other thing. These kind of predictions are very, this algorithm where people are nowadays doing a lot of work on this one. Actually, AI based this kind of early prediction makes inroad into almost all disciplines. Every day you can able to see that. That is correct. So that is the main thing. And this is something like this, no? Suppose I got information up to time point TV, and suppose I want to say this is the point where the patient, here this patient is cured, where this patient is still there. And based on this one, can I able to say the patient will be responding or not? this patient won't be responded. So you have to predict it, correct? The existing survival marker can predict until TC. So develop Bayesian approach is a prediction of other things, correct? So early prediction. So that is the thing where a lot of machine learning approach has been used, and even though the sparsity of data, and here I'm giving the method even for the survival analysis where the data is going to be partially incomplete, correct? Incomplete, not missing, incomplete. Some information is available, not full information. So these are some of the other approaches. The only thing just with this, I think, we are having a lot of, we said Cox model, we are having linear regression, random forest, naive Bayesian, then Bayesian network, then early prediction, early stopping rule, then naive Bayesian, then other things. You can be able to see the occurrence of the events information, the accuracy even with the 20% data, these three algorithms, the accuracy is going to be more than 70% to 85%, correct? Which are the things? The black line is going to be this one, Bayesian network. The second one is going to be ESP10. The last one is going to be naive Bayesian, correct? So that is the thing. So for early prediction, instead of all the things we are having, because this we said already, we have seen these are the pattern. So this one, the tree-augmented naive Bayesian TAN and naive Bayesian NB and Bayesian network. So these networks, these are the functions we are having prior information. This is the way it has been calculated. So you can be able to see these methods perform better even only 20% of the information is available. I can be able to predict because it's going to be accuracy is going to be 84% at the 40% level. Where these methods, classical methods, when you are at 100% data, all the models are almost giving good results. But 80% of them, most of the method fails. So even the conventional Cox model, the blue line, which are using for high dimensional data, it fails. The linear regression, which are having, this also fails. Random forest is supposed to be one of the best method, but it also, when you are dealing with this one, it fails. Naive Bayesian, everything somewhere, but the early stopping rule, because this is going to be, these are the things where having Bayesian approach, we are getting it. So this is only to show that. I think there are other methods, don't bother yourself. I think probably we can able to, don't want to do much on this one. Calibration, stratified random variable, because this is one of the important things. So, but whenever you're building a model, for example, COVID, we want to Chennai. So, one of the things, almost all model, we assume the population is homogeneous. In other words, the risk of getting a disease for everybody is same, correct? That is one of the things which is not true. That means the risk, there will be a lot of subpopulation where having different risk functions, then having a common function not there. Then try to stratify the population and try to build separately the model for each of the subpopulation, taking the parameters separately and combine them in an optimum way. So that is going to be there. Then competing risk. So most of the times, so even COVID, we say that there are comorbid conditions, not only the disease, the persons who are having diabetes, persons who are having hypertension. So what you are going to combine, if two or more causes are operating on the same individual, the death may be due to any one of them. Suppose you are having, these are the failure times of kidney T1, T2, T3, T4. Suppose the patient dies of stroke, that means the failure time of kidney, everything is going to be higher than this one, correct? Therefore, what you are having, the minimum order of T3 and cause is going to be the cause stroke, we are going to get it. The problem is there are two major problems here when you are building a model. The first one is these diseases, in most of the times you assume, T1 you are having, these are the variables X1, X2, X3, X4 are the four causes. Then we say the causes are independent for building the model. That is not true, correct? They are highly dependent. The second important thing which we are going to say is heart disease, the stroke, this one, the death, the distribute. Theoretically, what you are trying to do is, suppose you are having the joint distribution, let us say F of X1, X2, X3, X4 is there, and I want to get the marginal distribution. No problem, because we X1, if you are independent, simply integrate it, you will get it. Suppose X1, X2, X1 is still the methods for this one. Here the problem is, once I am getting the marginal distribution, let us say F1, X, F2, X, F3, F of X1, F of X2, F of X3, F of 4 functions, and I want to get the joint distribution or joint density, where X1, X2, X3, X4 are not independent. If you are independent will simply multiply. If they are not independent, that's the problem, correct? So most of the models fail here, and whatever model you are having, this aspect is there. So competing risk is another approach by which you can able to get the model. There are a lot of ways for here this method what I am giving, this is already used in most of the survival problems. How this can be extended to high dimensional numbers, correct? Okay, I think with this need not be recurrent event. So, and whatever I said, there are softwares are available. So most of the things, the basic cost, 3D cost, whatever in the package is available. Similarly, we are having the machine learning based approach like Bayesian, random forest, boosting, everything you can able to get it. The only thing, only for the multitask learning, which you MATLAB is there because there are some codes available in R, but they are not useful. And the transfer learning is another important thing where people attempted to get, but still C++ codes are better. All other things we are having R codes for this one. We can able to do it, particularly the early prediction, on sensoring, everything. These things are available, and so the whole idea is models for high dimensional database is the idea, where a lot of work is needed in this area. Conventionally, we know lower dimension, we can do a lot of things, lot of bits is available. What are the important developments? So I have given some of the other machine learning approaches help us to build models for this one. How the same machine learning approach model can be extended even in the case of longitudinal data with incomplete observation, correct? Incomplete observations. So ultimately, whatever model you are having nowadays, based on the database, you have to create a model, you have to make the prediction. So you are going to get the projection, or it's going to the forecasting, or estimation, or prediction. But the four terms have got different meaning. One is the projections, the other one is forecast, the other one is going to be estimation, the other one is going to be prediction, correct? So the forecast is a very loose term. Sorry, the projection is a very loose term. Then slightly with higher condition, we're getting the forecasting. Still with the other thing, we're getting the estimation. With further conditions, we're getting the prediction. Correct? The prediction is the most. So we got a lot of this one. The whole idea of my thing is to about 3 days back, people asked me to take this one, and I thought, no, being mathematics students, this is the area where people can do a lot of wonders. Those who want to write a project or get some funds, this is the area where you can venture. And the same concept, whatever we are having, if COVID data is available, try to build some of the models, particularly the early prediction models, see whether you can be able to do it. Individual data is available. Otherwise, you can be able to do it. So with this, I think, since the first day, I don't want to bore you much except to give a brief introduction about the recent developments in the modeling, particularly of high dimensional databases, correct? So that's what I'm trying to do. So, okay, now what I'll try to do is, another 10 or 15 minutes, people have got any doubt, just you can ask me. I'll try to clarify it. Yes, please. Hello? Hello? Hello?
Professor GS, would you like to ask any question?
Yeah, it was a very helpful lecture, Professor.
Goindarajan, கேக்குதா?
Okay,
Yes, sir. Yes, sir. Yes, sir.
It was a very useful lecture, but I read in newspaper last week, one statistician wrote about a famous quotation of a statistician. All models are wrong, but some models are useful. Would you like to comment on that?
Hello, Professor Venkatesan.
I think sir is not available, sir.
Oh, he left, I think. Maybe the connectivity problem.
Yes, sir.
Yeah,
Sir joins.
yeah, you will come.
Yeah.
Any clarifications are needed? Can you able to hear me?
Yes, sir. Please, sir.
Oh, my name is P.Venkatesan, not R. Venkatesan. Somebody put up.
Yes, sir. Sir, Professor GS asked one question, sir. Professor, can you repeat the question?
Yes, yes. I read an article written by a statistical
Professor.
professor.
Okay. Tell me.
Professor?
Yeah, tell me.
I read an article last week in Indian Express written by a Indian Statistical Institute professor, where he has quoted a famous saying from a statistician stating that all models are wrong, but some models are useful.
That is the fancy, people used to say the problem is the models can never be long because it's like a tool, like a penknife, correct? Whether you are using to sharpen the pencil or cutting your finger, it is not the fault of the model. After all, they are equations. The thing is, when you are applying this one to any of the field, you should have sufficient knowledge in this one. Ultimately, what you are doing, a real world problem, you want to translate in terms of equations, correct? You want to capture it. How good you are capturing? When you should be very good in mathematics, or statistics, and you should be very good in the field which you are applying. Otherwise, you'll borrow a model, somebody is applied this one. Models are just like, it is equation tools. You cannot blame the model. If somebody is cutting their finger, you cannot blame the knife.
Yes.
People are unable to handle it properly. That's the problem.
Correct.
See, all models are only approximations, correct?
Yes.
What you are having, any real world situation, you want to transfer, a real world process, you want to capture, these are equations. How best you have to capture? Because we got a lot of theory. If there can be something like we expect, this could be one of the possible things. And one of the important things we have to remember is the tail end behavior of the cows are entirely different, because the cows may be in the middle where most of the cows will be the same, but tail end behaviors will be entirely different. So that you have to remember. And all models are approximations, and we never claim that the models give exact solutions. It is only an approximation of the real situation.
Yes.
Correct?
Correct.
That is the idea. I think some people are fine. That was told by one of the non-mathematical persons. All models are are useful. That was told by one of the physicians, because normally they used to tell some of the comments. That is the way it has been done.
I see.
Otherwise, some people will be fancy, because we are having that is the way. Yes, sir.
Thank you, Professor.
Hello.
Yeah.
Yeah, this is Dr. Ritesh Dubey.
Yeah, please.
Yeah, sir. Actually, I have one question.
Yeah.
Like, what about the overfitting of model and how we can avoid it, and some light on the dropout techniques?
Yeah, so there are two things. What you are saying is correct, because the bias and the areas is going to be the major problem. Any of the things is done only by trial and error methods, correct?
Yeah.
It is going to be there, because that is a common problem. Now, even in the conventional thing where you got large volume of data, the problem of overfitting will be there because number of parameters. But here the situation what you are having, the number of parameters are more. We are not using any of the conventional parametric version to get it, but we are using the problem of based on the data we try to get the estimates, and it is that's all, because the problem is always there. You are any model fitting, the what I call the bias and variance concept will be there, overfitting will be there, and definitely when I'm dealing with high dimension databases, but if we are having a conventional fitting, definitely it will be overfitting. But the approach we are not doing in the conventional way, the machine learning approach based on the database, we try to have the algorithms to get rough estimates for the parameters.
No, but nowadays when people are using neural network and machine learning for image classification, segmentations, in that case, how to avoid the overfitting? What are the techniques available for those things to avoid the overfitting? And also, like normalization is one of the technique which is used for training the neural network efficiently.
No, yeah, that is true. See, normally most of the times you will using your exercise should be normalized, because there will be a better fit, because otherwise each of the variable have a different measurements. So normalization is one. Even among normalization, the packages nowadays they will say only standardization. The Z-score they call it a standardization. But normalization, as you said, one of the things, all the things should be normalized. Even in a regression problem, we are normalizing, because we are having a BP as a function of age, height, weight. I want to fit it. Then BP is going to be H of mercury. Age is going to be in years and or months, and weight is going to be in kgs or grams, and height is going to be centimeters and meter and different scale. My assumption is these betas are additive, correct? So to do that one, what I am trying to do in a conventional equation problem, I bring everything to the common scale. So make Z age as a standard normal distribution, Z transform, and this solves this one, and everything will bring the common scale so that beta can be additive, correct? That's the way you are doing it.
So let us look at a regression problem, sir.
No.
Because I am actually stuck somewhere in my own work.
Yeah.
So let us look at a regression problem where I have two neurons in the input layer. Okay, and output layer is one neuron and some hidden layer. Maybe you can talk about, you can think that it's a vanilla neural network where we have two input neurons. So basically we are sending, the input is a R2 vector. If I normalize this input vector, so for example from -1 to 1 or 1 to 0.
Okay.
In that case, for the whatever data we are taking, unscaled data, after scaling it will become 1 minus 1 or 1 or 0. So in this case, all the time network will have the same input, and if the target values are different.
No, you cannot get like this, no? You cannot get something, you cannot get like this, because we are having, there are two things. So that means you are having, your weights are going to be almost negligible in all the columns. So your inner product value is going to be almost the same for all the things, irrespective of whatever exercise.
Yes.
Then in this case, how it can happen? Because there are some problems. Because your exercise, or even if you normalize or you standardize, your weights are going to be there, and you are going to add it as simply inner product, and you are going to apply most of the times the logistic transformation. So sigma transformation, you are going to apply some threshold value, you will get it. Everything you are getting the same value means, that means most of the inner product in the hidden layer itself, we are going to get the value less than the threshold value. That means not firing or communicating with the next neuron. That means every time you are getting the same value. That could be the problem.
So let us, sir, I probably I have not made my question very clear. Let us look at an example where we are giving A and B to the neural network, only two values, and we are getting the product of this value, like A cross B.
Okay.
Just scalar values A and scalar value B. So there are two input. So one neuron is getting A, one neuron is getting B, and we are getting output as A cross B, the multiplication of AB. Now if I scale this input vector AB from 1 to -1 or from 1 to 0, so product will be always same. Whatever AB I am giving, because after rescaling, it will be always +-1 for each pair of AB.
Now, two things, there are two things. You are having a bipolar function, definitely you are having -1 is going to be what they call negative, and +1 is going to be positive, is okay. Or some person, even if you are having 0 to 1 also, where less than 0.5 is going to be one group, you can code it in any way you like. That's not a problem, isn't it?
No. What I'm saying is, if I am designing a neural network where we have two input neurons and one like output neuron, so the input neurons, how we can normalize? Because, for example, in this case, AB, if I am normalizing, I am giving either 1 or -1 all the time, and the output will be always -1, the target value. So it is actually a replica of many, like all the pairs, input vector and the output vector is going to be the same. But unnormalized data will be different X and Y, different A and B, and then AB, the product is also always going to be different. After scaling, it is going to be a unique value all the time. So how we can avoid, because when I'm doing this, I am getting this, because after rescaling, the things are not coming in a proper way in some cases. So I was thinking maybe this is because of the overfitting.
There seems to be one problem, because every time you are going, your input is going to be 0, 0, 1, 0, 0, 1 and 1, 1, correct? That's what you are telling.
Yes.
Huh?
Yes.
This is a simple XOR problem where we are going to have it.
It's a binary network, I would say.
Yeah, that's what you are telling, only two values. Then naturally we are going to have either R condition or uncondition is going to be there. Then in which case you will have the same value, you will get it. Because after all, it is the problem which I have shown, the rectangular problem, where we are going to opposite vertices are going to be one thing. Unless you are going to map it to the second dimension, in the hidden layer, the function which you are having, the activation function, you have to use it so that you will separate. So map to a higher dimension, otherwise you will get the same value.
So basically, learning such kind of function like multiplication of two values is not possible for the neural network after the normalization.
Yeah, because neural network is supposed to be parallel architecture. Parallel architecture, because there is no connection between the layers. It is only parallel architecture because X1 everything is going to be there. So we are having even hidden layer, everything is going to be there. There is no connection between the layers, correct? You are having hidden layer, suppose you are having hidden layer 1, then there is no connection between the neurons. X1 and X3, they are independent. Because that is because brain is supposed to have parallel architecture,
No,
and you have to map it. So the translation be done less one.
It's a fully connected architecture.
No, fully you can back connect it. There is no way of connecting. You are having hidden layer, you are having H1, H2, H3, hidden nodes are there, H1, H2, H3. In your hidden layer, suppose hidden layer number 1, you are having 3 neurons are there connected. So the neurons are not connected. It is only parallel because that is the parallel architecture. Because brain is supposed to have the parallel architecture. I'll show you this. Yeah. Just a minute. Yeah. Here, so here the H1, H2, there is no connection between H1 and H2. You cannot connect this one. Because the architecture here is, because brain is supposed to have parallel architecture. So this is going to be one layer and this is going to be another layer. There is no connection between within this layer, there is no connection here. Similarly, we don't have, here there is no connection. Here also, suppose one more hidden layer is there. Connection between layers will be there, but within a layer, the nodes are not connected. What you call the neurons are not connected. That is architecture.
Okay. Sir, can you suggest some good reference for mathematical introduction of this neural network?
I think the Bishop book, the neural network by Bishop.
Okay.
Very good book. That Bishop is, whenever you want to do mathematically, Bishop book is a very good thing. Then other 3 or 4 books are there. And you want to have the application for this one, Baldi is another book. And you are having, what you call, okay, I'll send you because there are a lot of books are available.
Yeah, you can send it to HOD Mathematics.
Okay, no problem.
We can forward to all the department faculty.
No problem.
Yes, sir.
Yes, sir. Any other questions, sir?
Sir, you said the hidden layer is not unique in your talk. So it is left to the researcher to choose the hidden layer, or it will come automatically?
See, normally I told you, whenever in neural network, one hidden layer, there should be minimum one hidden layer, correct?
Yes, sir.
But the one hidden layer will be there, but the number of neurons are arbitrary. 2 neurons or 3 or 4 is arbitrary. But one neuron, already the theory says, a neural network with one hidden layer can able to approximate more than 95% of any complex function. Okay. That means for all practical purposes, one hidden layer will be sufficient. But when you're doing with the high dimension database, one hidden layer may not be sufficient. You have to go for 1 more, or 2 more, or 3 more hidden layers. Correct? The only thing is the inputs are fixed, output is fixed. The layer, number of layers are arbitrary, and within the layer, the number of neurons are the nodes are arbitrary. So you have to, by trial and error, you have to get it. But there are certain rule of thumbs. For example, one of the important things, you are having a single layer. How many neurons you should have it? One simple rule is the number of input plus number of output. The average of that one is going to be starting point for that one. Correct? Okay. Starting point. And then if performance is not there, you can increase the number of nodes. Still it is not where is there. So as Dubey was telling, the only thing is, your exercise, you should not give the exercise directly. You have to normalize it so that to get better result. You are giving then the inner product will have different combinations is very difficult. So everything should be normalized. The options will be there in almost all the packages. And there are even the neural, tools, neural tools are there in our programming. I think it's starting from SPSC, everybody now started doing this neural network thing. But best package could be the MATLAB, because the optimization toolbox is there, neural network toolbox is there, and where the optimization toolbox consists of now this version genetic algorithm separately, where you can do a lot of work on that one. For high dimensions.
Okay. So one more question, sir.
Yeah, please,
usually transformation will vary from case to case basis. So how far the researcher will have to choose the transformation depending upon the situation.
Which one, sir?
You said transformation. You are moving from high dimension to lower dimension. In some cases, lower dimension, high dimension. So transformation, you are using sometimes projection, sometimes hyperplane. So how the researcher will choose the?
It is no. It depends on whether it is a classification problem or a clustering problem. Correct?
Okay.
A classification. See, this kind of network, what you are having is a patient. Suppose first, so let's say I got 100 cancer cases, 100 non-cancer cases. I got each cancer patient. I got about 200 variables. Correct?
Yes.
So 200 variables I cannot, so I'm giving, okay, for the simple reason, say 2IX or 200X I'm giving it. So ultimately, first case one, I'm giving the values. I will start with some initial weight, W1, W2. I start with normally from 0.03 minus 0.03 plus 0.3 will start. Then we give the first case. So it is only a matrix multiplication. This Xi corresponding WH, you will get it inner product, correct? This will get value. Here also will get value. Then the inner product, you will apply certain transformation, particularly sigmoid function, S function. So then you will get it the logistic function. So then we'll say that after transforming this one, it will become 0 to 1 value. You say that it is 0.5 is your cutoff point. If it is 0.5, you want to say that you communicate to the next layer. Less than 0.5, what you call in neural sense is not firing. Similarly, we are going to have it, correct? Then once again, we are going to the value. Ultimately, you get the inner product once again here. Apply the transformation with the same transformation, some other transformation. You will get a value from 0 to 1. Suppose the value is going to 0.6. You are going to predict as a case. Let us say 0.5 W is a case based on this one. But you are given the non-case values you are getting as a case. What you have to do is, you have to go back. You have to adjust the weights here. See whether adjustment weight you are getting a non-case is predicted as a non-case. Still not there, go until a case is predicted as a case, a non-case is predicted as a non-case. So you have to give sufficient data so that after learning them, all the weights become stable. This is that means the network has learned. So what Dubai was telling, sir, if you are giving the certain things, if it is overland from the data, then it may not be a good prediction. That is true for almost all the models. So what we are having is, so we say that what is the correct classification. Then about 1,000 cases there, 700 cases used for this kind of thing, cases and controls, the weights are stabilized. Then remaining 300 cases there, then I'll give this one. Now the algorithm is the tool, is the trained. Give this one. Suppose I'm giving a case, it predicts the case as correct. Suppose it gives us a case as a non-case, is a misclassification, error, correct? So like that, about 300 cases I'm giving, it can be able to correctly classify 250 cases correctly, 50 cases wrongly, correct? Then the classification, misclassification error is going to be, then 50 by 300, where it's going to be 1 by 6, about 16-17%. It is not acceptable. So we'll try to increase the layer, or is going to be one more layer at the nodes until the network. First, the Xis are standardized. Then with minimum nodes, we'll start with one hidden layer. Till it's not performing, go back. Every time the weights will be standardized. But for most of the practical purposes, one hidden layer with 10 to 15 in nodes layer can able to perform the per high dimension database. Correct? Very rarely we may need say a second layer because the variables you are considering, it has to distinguish a case and non-case. Because you are having hypertension, you say that then you are having your BP parameter, it is going more than 1 to most of the cases will be above 120. But even the hypertension case we are calling everybody is going to be under 10, then you cannot, that is not a good predictor. So the selection of that one is going to be very important. That's the whole idea. Now here my aim is how this classification problem, how the model can be built by making as a what they call classification, how correctly you can able to classify it. And similarly, if suppose the output you are giving it as is the continuous thing, it become a prediction problem. Yes, sir.
One more thing, sir.
Yeah.
You mentioned about matrix. You are dealing with an high dimensional data. So the number of elements may be more, the order of the matrix may be high. So the matrix multiplication is automatically satisfied, or we assume that it is satisfied.
No, sir. I think that's what is right now. Suppose I got 2000 variables, I'm not going to give the input as 2000. The 2000 using the extraction or the selection method, I'm going to reduce the variable manageable 10 or 15 or 20, correct?
Okay, you are going. Okay.
Yeah, you cannot go 2000, 20,000 matrix. I cannot able to do it, you know. Even olden days when you are doing our thing, IIT computer, even 15 by 15 matrix in the IM as a library, it will take a minimum 2 days to get it, no?
Okay.
Now we got, see, that's why when I'm being IIT administrator, you are having 10 or 15 variables, you give the exercise as it is. You are having, let us say, 10,000 variables, you cannot build a 10,000 variable network. How the 10,000 variables can be transformed to other set of variables or best subset of variables so that your exercise are minimized, correct? That is going to be there.
Okay. Okay.
And you are having only the inner product, no? Because each xi multiplied by corresponding weight and sum for all the nodes, you are getting sigma wi xi for the first one, this one, and that is going to be a number. That number you are going to apply a transformation like log to make the from suppose this value is going to be 20 point something. Apply log, you will get the value. Some in terms of whether taking log 2 or log 10 or log whatever your base you are having. So then, suppose the value is going to fix the parameter value is 0.5 and above it will communicate. Then the threshold value 0.5 means the next it will communicate 1, it will communicate as the way I was telling. Otherwise, this will be 0, it won't communicate this. So the way that will be 0 into W1 you will get it. If you communicate, you will get it, correct? So that's what we're going to do. It is simple matrix, what I call multiplication. After all the multiplication, you know, you get a number. The number will be of a different scale. Make it a common scale, what you call the normalization technique. And try to get it on the threshold value. Normally, when I have two-way classification, 0.5 is default option. If you want, you can fix 6 and above, you can have it, or 4 and above, you can have it, depending on the situation. That you have to try, correct? So most of the times when you are applying this one, the domain knowledge plays a vital role to some extent. Or before that, if you don't have this, discuss with the people in the field. Building model and learning, this one is different. Applying to real data and interpretation is different. So you should have both the things together.
One more last question, sir.
Yeah, please go for
and what about the time complexity? Usually it will be polynomial time or log 2 to the base E or any other.
Very good question. Very good question. I expected this question from somebody. Oh, now I said no. Why this network is better than another one? No, kernel optimization problem.
Okay.
It is only polynomial. This one. This is going to be very long. Whenever any learning algorithm, the time is going to be very high. Correct? Because everything you are going to do it. But here, the real linguist function, the time was very short because you are making an optimization problem.
Okay.
Correct? Yes, you are absolutely correct. Because I was thinking somebody, nobody has asked this one. Okay, you will keep it quiet.
Okay. So depending upon the situation, the polynomial time will be.
Yeah, it is better. Okay. But you know, that's not a big problem. So instead of 0.34 seconds, it will be 0.21 second. But now everything depends on the computing power. No.
Okay.
Now, because of the advancement of information technology and computers, we can able to do all the calculation, whatever I said, the development. 10 years back, we never thought of doing this one, even picking a Cox regression model. So, when we were having our thing, when we did in this one in the early 80s, to fit a Cox regression model, we have to write from applied statistics, we have to borrow the codes of photon programming, you have to write it, you have to run it, and you have to do all the things. So, that is a big photon 77. And now, whatever we done for 2 days, 3 days, now it has been done in fraction of seconds. That's not a problem.
Okay. Okay.
That's not a problem.
Oh, okay, sir. Thank you.
Because the we can able to do all these advancements mainly because of the advancements, because the computer science, because computers are so powerful in terms of managing data. Previously, you know, even even now the calculator, no, you say that up to factorial 69 will give, if you put factor 70, it will give this one. After all, the capacity is going to be 2 power plus 32 to 2 power minus 32, correct? Plus 31 actually. 31, that is the capacity you can able to do it. After binary digit, all the information converted in binary. So 2 scale. So the maximum number it can hold is only 2 power this one. So most of them what used to do it, any multiplication problem convert it as in terms of log, try to do it additional problem, do all the calculation and revert it back. We are very good in making transformation. How to handle it, we know that.
Okay. Thank you, sir. Thank you.
Yeah, any other questions?
Any other question from the
Yes, sir.
audience?
Yes, sir. Yes, sir.
Please,
Sir,
please.
good evening, sir.
Please.
Good evening, sir.
Good evening.
I am Balaganesan, sir.
Yeah, please.
Yes, sir. Sir, in your talk, you used probability as well as fuzzy concept. May I know what are the distinction or what are the difference between probability and fuzzy?
I think all professors I thought I can. Okay, I will give you a simple example. Okay, what is probability? What is because fuzzy concept, probability is the what you call. We are going to probability definition. All of you know it is relative proportion is taken as probability, but actually you want to define probability. You have to have the three number. You know, the sample space, the measure, and sigma algebra should be there. That is a classical way. But all practical purposes, we are taking the relative frequency as an approximation to probability. Correct for real thing. Correct. That is the way we are doing it because any real world problem. So theoretically, you are mathematicians. You have to say only in terms of sigma algebra. Correct. I will give a simple example to understand. Suppose if I say your age is around 30.
Okay, sir.
Correct. It is an what we call imprecise information.
Okay.
Around 30. But suppose you say your age could be possibly 30. Correct. It is uncertain information, correct? Suppose I am saying you are young, that is fuzzy information.
Around 30 also fuzzy only, sir.
No, the fuzzy is only a qualitative thing, correct? Younger old, the cut off my point to be there. Suppose fuzzy is a good, no? Suppose I am saying a good by, I will define good because most of the linguistic variables. So the whole thing of fuzzy is because in I already told you during the talk, in terms of mathematics, a probability concept, the sample space is fixed, the events are mutually exclusive. We add all the events, we'll get the sample space, correct? The probability is going to proportion. But in fuzzy, the boundary is fixed, but the events are overlapping. So no, they are not mutually exclusive. There are common areas between both the things. But in rough set, even the boundary is not fixed. Correct? That is the idea. That's the idea. So most of the problem is most of the times, if you are having very good numbers, okay, but real life doesn't use numbers. In fact, you are dealing with biological information. Most of the informations are qualitative in nature, and some of them are highly fuzzy. I say the genes are overexpressed, null expressed. Because the problem, suppose you are sick today, you are taking a drug, tomorrow the doctor asks, I feel better. How to quantify that betterness in terms of numbers? Very difficult, correct? They are qualitative things, so that is going to be the problem. But we have, what in mathematics, we are in one domain where we are very good, comfortable, and this one. When you want to translate to other things, every time we are looking the same concept, it is not there. Now, see, we spoiled mathematics because in the college level, in the university level, we made it as a dry subject. Now you can say applied topology. We got applied tensor analysis, everything can be done. I given one example, how the Hilbert space concept has been used in support vector machine, correct? That revolutionized 1995, a very good concept, correct? Similarly, now recently we are having applied tensor analysis, applied, what you call, all the things have come, applied topology, everything has come, correct? So we have been taught, mathematics we have been taught only as a dry subject. But unless you say the application there is very difficult to understand. That is the thing. Okay, but I think future is not like that. Whatever you are doing, all mathematics, you can able to relate to real world things. We can do wonder. After all, no. See, mathematics deals, all of you know, only with the both things, correct? One is the, what you call the quantification. The next one, it measures what you call the change. Next one is the structure and the shape, only four things. If you take any science, it will take, it will measure, it talks about the shape, it talks about the, what you call, the structure, it talks about the change. So, as far as the quantification is concerned, all numerical mathematics, you talk about the, what you call the shape, the shape, trigonometry, geometry, etc. If you take up the structure, algebraic structure, topology structure, etc., and change the whole calculus, differentiation, integration, everything, that's why without mathematics, no science can survive, because all science are doing only the 3-4 aspects they try to quantify. Without mathematics, no science will exist. That's why I say that science is the queen of all science. Is the queen of all sciences. Without mathematics, nobody can be able to do it. The only difference between mathematics and then 2 + 2 is always 4 in mathematics. But in real world, we cannot measure anything 2 grams or 2 centimeters exactly. So if you are having 2 plus 2 there, it won't be 4, it will be 4 plus something or 4 minus something. So the concept means added the error term so that making certain assumptions. Within that, we can able to do it, correct? And fuzzy further relaxes the uncertainty where you are having what you call almost. And whenever you are relaxing certain assumptions, the more generalization is happens. Okay?
Sorry, sir. More general.
Any other question?
Hello.
Hello?
Hello.
Please.
Hello. Hello.
Sir, சொல்லுங்க.
Hello.
பாலமுரளி சொல்லுங்க.
Sir, okay.
Sir,
Sir, do you analyze current COVID-19 data, sir? Sir, do you analyze current COVID-19 data?
I published day
Hello,
before
sir.
yesterday. I published one paper in the Journal of Statistics and Computer Applications. I published one paper.
Oh, okay, sir. Okay, sir. Thank you, sir. But
So,
sir, when we get the
comprehensive modeling and what do you call approach for prediction of comprehensive approach for estimation and prediction of COVID-19 cases in India. Just I published about 3 days back. It has published.
sir, what is your conclusion, sir? Hello.
Conclusion. I think I'm telling you one thing. You know, to be more frank, it is shooting at the dark and painting the target where it lands. To be more frank, openly we are telling, because we are in the early stage of the curve. We don't know how the curve will, because we are still in the early stage of the curve in India. Initially, we are having this one, and all of a sudden goes. Most of the times, you might have seen approximately exponential are going to be, even the path is going to be approximately exponential. But it is not dominated by exponential. It can go to any other. The situation, if everything goes right, we expect somewhere in October we will be getting the downfall from October.
Sir, peak when we get, sir, in the epidemic curve?
September,
October. September, October.
Yeah.
Sir? September, October.
Yeah, September or October.
Sir, do you calculate any death rate, sir? Death rate?
No, actually, my approach is different. What I did was, my approach is based on the back calculation approach. I am not going for the SIRD or all the models where people are done. What I did is, the incubation period for a COVID case varies from somewhere from 3 days to some 20 days or something. I've taken 2 weeks as the incubation period. I am assuming a different distribution for the incubation period. So today I am getting so many cases. What could be the possibility of getting the case from 2 days back, 3 days back, 4 days back? And the infection density, I am going to assume it. What we call how it spreads between individuals, how it progresses within individual. Then so I am using what we call a more mathematical form, not the conventional approaches. Then based on this one, I have made the logistic infection curve based on this one. What are the under variable model, under gamma model, under log normal, under staging model, change point model, and we are having a mixed variable. So various things, and I can able to say most of the models converge at this point, and we expect the referee actually asked me to give the when I sent the publication for last month. They said to give me the prediction for next 3 weeks of June. I given my values are slightly higher than what has been observed. I told him there are underreporting, which could approximately it has been accepted. Probably we have to see, because very difficult. Nobody can able to say that my model is better. Only thing is, just we are giving an approach by which we can able to do it. That's all. And because of our experience in HIV projections, which I did it, and we are trying to use some of the concepts which are used there to a different approach, where people have the infection model, where you are having susceptibles, infected, recovery, death, and a lot of other compartments. We are using a different approach. Because
sir, some other scientists already told this COVID-19 is equal to HIV. Is it possible, sir?
No. It is not. HIV can spread only through the sexual route, correct?
Yes, sir. Yes, sir.
The mode of transmission only through HIV. If you are having HIV patient, you are touching, won't get it. You can move it, there won't be any problem. It is only blood to blood transmission, correct? It is going to be there. Sexual route is the major route, about more than 85%. The only thing is some of the concepts. Once the virus enters the body, normally it will take 3 weeks to 5 months for an HIV virus virus to manifest itself at that level. Whereas here, 2 weeks, instead of months, you are having weeks, so that is the thing. But HIV person won't die so quickly because the virus is going to be there, and that's not so fatal like this one. The problem is that the COVID-19, the problem seems to be because it affects the lung, because of this one, oxygen transfer is not going to throughout the body, because of that multi-organ failure occurs. The death is not to the virus because of the oxygen transfer is and multi-organ failure.
Okay, sir. Sir, thank you. Sir, one more question, sir.
Yeah.
In principal compound analysis, then we go to PC3, sir.
PC3, see, normally what used to go is any principal component we are having the scree plot, correct?
Yes, sir. PC1 and PC2 percentage calculated, sir.
Yeah.
Based on the eigenvalues.
Whenever the principal value is going to be one or more, that components used to take it. And not only that, the value should expect at least more than 95% of the total variation to capture. For example, one of the data we are having the skin data, the dimension of the data is going to 2,500 variables, where we can able to get about 54 principal components can able to capture about 99.3% of the total variation. So instead of using that 2,000 variable, just 2,500 variables, we have used only about 54 what you call the principal components. Where the classification seems to be almost 97.8 or some percent, something like that.
Sir, most of the database they downloaded from JITCUP and WHO, sir. Any other database are there, sir?
No, database maybe then nobody will give
JITCUP,
nobody
sir,
will
most of the data belongs to only JITCUP, sir.
See, the problem is these kind of sensitive information nobody will give you. Even HIV data was not given. Even today, you want to give the HIV data with the patient details, nobody will give you. These are sensitive matters, correct? And
yes, sir, yes, sir.
a lot of government things are involved. As long as you are saying that they are good, is okay. If you are making your positions are going to be on the work other way, then you are out. So then a lot of problems will be there, not only for you, your institute, and your the journal which are publishing. There's a lot of things are there. It is not purely science. There are so many other factors that have been there. And most of the times, they won't give the real data. Even today, you want to get the particulars about, let us say, about 500 HIV patients with all detail. Nobody will give you. Nobody will give you.
Okay.
Nobody will give you. Because even though HIV started somewhere in 1986, now you won't get the data, right? Nobody
yes,
will.
Sir, yes, sir.
And because of this one media hype, here nobody will give you the data about this one COVID-19. They will give the aggregated figures. With aggregated figures, you cannot able to do it. Suppose you are having the patient, let us say, we're having a number, let us say 2 lakhs of at least 1 lakh persons. We got all the information, the gender, the age, and all particulars. We can do some model. Nobody will give it. The only the aggregate figures they are giving. And that also you can see, if you are having the COVID tracker, it will give one figure one day, and same thing you have other common figure, we are having different, at least a difference of 10, 15 values are there. That is there in all. So with aggregated figures, we cannot do any high level modeling, I am telling you.
Thank you, sir. Thank you, sir.
Consolidated figures they are giving, and they are not giving any individual things. No.
Thank you, sir. Thank you so much, sir. Presentation was very nice, sir. Very nice presentation.
Thank you, sir.
Thank you, sir.
Thank you.
Any other question from the audience?
Yeah, this is Bapuji, sir.
Please.
Yeah, actually, somebody telling actually retrieval medicines may be useful for the COVID patients for HIV medicine. Is it possible, sir?
Which one? Okay, sir.
Retrieval medicines, the HIV medicines also they are applicable actually for COVID-19. Is it
COVID-19? I cannot understand, sir. Please.
HIV medicines also they are using the same medicines for the COVID patients.
Drugs,
Yeah, medicine, sir, medicine.
The medicine, that's what. See, now we don't have any drug practically. What you're trying to do is, since one drug, the virus already we got drugs are available for HIV, the viral drugs. They want to try with this one because nothing is available. However, the patient is going to die. At least we see that whether the patient can be served as the terminal patient. Not every patient. They are giving only the terminal ill patients. They won't give. We are not supposed to give. The patient who are asymptomatic, they should not give. Those patients whom we say that they are very serious. Where expert better they can be treated using any of the drugs. But remember, all HIV drugs are highly toxic. Highly toxic. For example, I tell you there is one drug called Nevirapine. That if you take the drug, you will get lot of dreams. A lot of things will be coming. People are telling, the patient will tell. All dreams, all color dreams, everything will be coming. And highly toxic drug. And they are costly also. For example, efavirenz is one drug is there for HIV drug. Each tablet costs about 90 rupees or something like that. Very difficult for any person to buy. Now, India, we are supplementing the drug free of cost for all the patients who are coming to the government hospital. Remember that. That is the best thing we are having. Central government is giving the drugs that you have to appreciate. No USC or UK, nowhere they give you free drug. Only our country from central government. Similarly, TB drugs we are giving free of cost.
Yes.
Everything has been given the government. There are so many things, you know. People won't appreciate that kind of thing. They will talk about all silly things, all dirty politics is playing in the country. And nobody will talk about good things. So what to do?
Thank you, sir. Thank you, sir.
Thank you. Thank you.
Yeah, any other questions from the audience?
Most of them could have left already.
Sir, I would like to ask one final question.
Yeah.
Even though all the people are affected by COVID, irrespective of the age group, this COVID is having affinity with gents rather than ladies.
You are more exposed. You are more exposed. Because gents are moving more, and naturally we are going to have. And second thing is you are having comorbid conditions, because smoking is there, drinking is there, everything. Only males are dominated by this one. You know, other risk factors are more in males when compared to females, and mobility also males are more compared to females. Correct? And that's the reason why we are getting it. Otherwise, there is no discrimination between males and females. Probably one reason could be females are not that much exposed to the outside world and compared to this one particularly. That could be the one reason. Otherwise, you know, it is there is no gender bias, and we cannot talk about the numerator. Based on the numerator, we cannot talk anything. Suppose if I say that no, there are 100 accidents happened in your SRM University, near SRM University, where 90 are males and 10 are females. Can you say that males are worse driving? Can you say that males are worse drivers than females? It is not like that. We don't know the denominator. We don't know the denominator, correct? Or to put it the other way, suppose out of the accident, 100 accidents, 90 accidents occurred in the side of the road, only 10 accidents occurred in the middle of the road. That is, walking in the middle of the road is more safer than walking in the side of the road. Can we make this? It's only numerators. You should have the denominator. All the 10 persons who are in the middle of the road could have died. There are about 1,000 people, only 90 persons who are having the side of the road. So unless you are having the denominator, most of the people are making only the numerator. Even the COVID condition, no, if we talk about prevalence, all the cured cases should be excluded, correct?
Okay.
What are the number of positive cases are today? You have to say, you have to exclude death, you have to exclude the cured cases. These are the active cases on today. But for everybody is giving the cumulative figure, the person you are cured, everything, and the number you are giving precision. No, how will you get it?
Okay.
Any kind of epidemiology study, we say that prevalence, that is old and new cases that are active as on date. You have to give it, correct? Not the cured cases, not the cases who died about 3 months back. But everybody is doing some kind of thing, and there is a big committee where people are talking new. Everybody wants to talk to the television. Everybody wants to give something. Okay, we'll let us enjoy the fun. There's a thing, you know. It is everything is political here. We cannot do anything.
Okay, sir.
Okay.
Thank you.
Sir, one more question from sir. I am Adityan.
Yeah. Please.
Sir, actually, you have worked on tuberculosis also, no, sir?
Yes, that was my area for more than 35 years. I worked in the tuberculosis institute where that was my core area. HIV and TB are my core areas.
Yes, sir. Actually, I also have one paper on tuberculosis while I was doing my PhD research.
Very good.
My question is, what do you think about tuberculosis infection and COVID-19 infection, sir?
Say this is virus, that is bacteria. Yeah.
That's fine, sir. But
tuberculosis is a mycobacterial disease.
Yes, sir.
Where we got drugs are available, and it affects the lungs, correct? But the period will be minimum 2 weeks. Cough with weight loss, with what they call other conditions. Then we say that the patient will be there. Once active treatment is started, even those it won't communicate to the other individuals, correct? Other individual. But COVID is not like that. It is a viral based. In fact, there is no drug for any virus to kill the virus, right? Even for common cold. So that means even your patient is in a, so the mode of transmission, the way of transmission differs. One other one is viral.
Because it is an airborne disease, but it causes more than what COVID-19.
No, the airborne is okay, but there are two things. One is, sunlight is there, a bacteria, even if you cough it, it will die immediately. And very rarely you receive it. Even you take it, suppose you're receiving some of the things, it locks the lungs, it will take at least 1 or 2 months to manifest itself as the tuberculosis signs and symptoms. Not like COVID, where you are getting today, you are getting contact within 2 or 3 days, you won't get it because it's a viral. And it affects, yeah, that's a problem. That's a problem.
Yes, sir.
Okay.
Yeah.
Any other questions?
One question, sir. One question. Actually, recently the Bharat Biotechnology, the medicine they have found this devil is right, sir? Actually,
which one, sir? Medicine,
yeah, some injections have found that something they said Bharat Biotechnology Hyderabad. In SRM University also their center, the testing the center they given.
No, that is vaccine, preventive action. Preventive action is not drug. What you are trying to do is just like smallpox, you are putting the vaccine to prevent. It is not drug. It is only vaccine for preventive action. And the trial has been on the SRM hospital selected as one of the centers for recruiting the patients.
Yes.
It is only for the phase 1, phase 2 trial, which are a small number. Normally, a phase 1 will be only on healthy volunteers. Now, healthy volunteers need not do, but directly they go in phase 2, which is the patient. Whether this vaccine can able to protect people from, they will take healthy volunteers, they will try to see whether it can be protected.
Yes, thank you, sir.
Thank you.
Okay. So, any other questions? Any other questions finally?
Yeah, everybody wants to know.
Okay. So, if there are no questions, I would like to thank Professor Venkatesan for giving excellent, inspiring and thought-provoking, useful, valuable lecture to our department people, our colleagues. He has given examples in every step. He has given examples in day-to-day life. He has also informed us about the opportunity to go for funding in the case of COVID.
Yeah, funding. My thing, whenever going, I'll say which are the areas where you can apply for funding.
Okay. So he has given a valuable suggestion to us. So I thank on behalf of Maths Department, Professor Venkatesan for giving this excellent lecture. So thank you.
Remember, basically I am a mathematician. I did my MSc, MPhil mathematics, then I switched over to statistics, MStat, then I gone for all other things. Basically, my first degree is MSc Mathematics, then MPhil Mathematics. I was first batch of MPhil student from the University of Madras. Then I switched over to ISI, gone there and did my MStat. That's how I became statistician. My thing is only on mathematics. Because basically, I'm a mathematics person. Then changed to statistician. Now I become a computational biologist, where bioinformatics, where we are having all the other things doing. That is my area, which I changed about more than 15 years back.
Okay, sir.
But still, the flower is there. No fundamentals are only from that one.
Yes,
still, I can talk about Hilbert's web and Space better than so many other people, new generation people there.
Yes, sir.
Okay.
We are very happy to have you in this first day of the lecture, sir.
Thank you, sir. I am also very much honored. I feel very much because SRM University is where when USC will be meeting often for most of the doctoral community students. Really, it's a very, very good experience. And I am very happy that I can able to, because even though short notice, initially I told Bapuji to give it on Wednesday. He said, sir, nobody's there on Monday. Okay, no problem, we'll do it. Because morning I was, up to 12:30, I was there with the other seminar in Presidency College, I thought then, okay, what is there? No problem. We can talk to our people, after all faculty members. Everybody is in the higher standard, we can able to talk. So that's why I accepted. So thanks, and I'm very happy to interact all with you. And any LPS leader, always be free to ask, send me mail. And whatever is available with me or with us, I can be able to give you. So be free to ask. That is the thing.
Sir, send us PPT also, sir.
Okay.
But,
PPT, presentation.
PPT also.
I will send it, sir. No problem. Always I will send it to you. I will send you. I will send it. Bapuji and Goindarajan, both of you are interactive. I will send it to you. No problem.
Thank you, sir. Actually,
Vardarajan, yeah. I will send you both of you.
Special thanks for accepting to our lecture in short notice and to be the opening batsman for the day.
Yeah. Today I'm opening batsman. So I try to hit some 6 and 4 so that other person can complete the match with good score.
We enjoyed your match. We feel that you have scored 200.
We'll hit some 6 and 4 to start the score. So other people will tail end. It is the duty of the middle order and the tail end batsman to finish the game in a very pakka manner. It's only opening batsman.
You hit your first ball 6, sir.
Yes, sir. Yes,
You
sir.
hit your first ball 6.
Yes, sir.
You hit your first ball 6.
Yeah.
And, not only that,
Okay,
you
sir.
scored a double century.
So starting is good means everything will be good, because once starting is good, everything is fine.
Yes, sir.
We fixed everything within less than 48 hours, sir. Actually, nicely we got it, sir. Thank you, sir.
Yes,
Yeah, thank you, sir. Thank you, boss. Thank you, no problem.
Thank you, sir.
Within 48 hours only we fixed that.
Okay, thank you,
Thank
boss.
you for all the participants. I thank all the participants for enjoying this lecture. Thank you, sir.
Thank you.
Thank you,
Okay.
Thank you very much for the wonderful session,
Sir,
sir.
kindly all of you fill this is what feedback from the chat box only. In WhatsApp we cannot. Those who have come here, then only chat feedback available.
Okay, no problem. Okay, sir. Fine. Bye.
Thank you, sir.
Thank you. Bye. Okay. So, all the best for the next 2 weeks programs.
Okay, sir. Thank you, sir.
Yeah. Thank you.
Babuji can end the meeting. Babuji can end the
Wait, sir. நீங்க feedback போட்டு அனுப்புறேன் நான் போறேன். Feedback போடு.
Okay, sir. Okay.
Thank you, sir.
Sir, you can leave, sir.
Okay, thank you, sir. Thank you.
So tight. Thank you, sir.
Thank you.
Sir, those who are not taking feedback and kindly it's a fill actually. Still we are there.
வந்துடுச்சு சார், வந்துடுச்சு.
இல்ல சார்
Feedback form வந்துடுச்சு.
வெயிட் பண்ண will be here only.
இல்ல அதுதான் சார் பெட்டர். வாட்ஸ்அப் வேணாம், இதுலயே அப்படிதான்.
நான் வெயிட் பண்ணேன் சார்.
ஃபர்ஸ்ட் லெக்சர் கீழே கீழ்ஸ்டாரு 3/4 மணி நேரம் क्वेश्चंस.
அத இவர் ஃபோன் பண்றாரு.
யாரு?
பாபுஜி சார்.
சார் சொல்லுங்க.
சார் ஒண்ணும் இல்ல, 10 மினிட்ஸ் நம்ம இருந்தா போதும்.
நான் பாக்குறேன் எல்லாம் பண்ண பிரச்சனை இல்ல.
ஓகே சார்.
நீ இல்ல நீ முடிச்ச நீ போ, நீ லீவ் சிவா. தேங்க்ஸ், யூ கேன் லீவ்.
thank you சார். பாப்பா லெஃப்ட் ஐல சார்.
யூ கேன் லீவ் actually. நான் லேப்டாப்ல இருக்கு, ரெண்டு பேருக்கு டெஸ்க்டாப் லேப்டாப் இருக்கு. நீ போலாம்.
ஓகே, thank you சார். thank you சார்.
ரொம்ப தேங்க்ஸ். யூ கேன் லீவ். ராதாகிருஷ்ணா முடிஞ்சா நீங்க போலாம்.
ஓகே சார்.
நான் பாத்துக்கிறேன். விஜி
சரிங்க சார்.
விஜி போலாம்.
ஓகே சார். thank you. ஓகே, thank you சார். thank you.
நானே
வெங்கடேஷன் போலாம்.
ஓகே சார். பை பை.
சாரி, தேங்க்ஸ் அப்பா. ரொம்ப தேங்க்ஸ் அப்பா. நாளைக்கு வாப்பா.
ஓகே பை சார்.
அது கொஞ்சம் வெயிட் பண்ணல, எல்லாரும் ஃபில் பண்ணனும். நான் அப்ப வெயிட் பண்றேன். நீங்க போலாம் சார். நீங்க எல்லாரும் கேன் லீவ்.
ஓகே சார். பை.
The remaining all of you can end the meet.
முடிஞ்சது.
பாபுஜி சார், பிரசன்டேஷன் அந்த இது ஷேர் பண்ணுவீங்களா அப்புறமா?
பண்றேன் சார். லாஸ்ட் ஃபைனல் எல்லாம் முடிச்ச அப்புறம் HOD பண்ணுவாங்க எல்லாமே. ஆல்
thank you.
ஆல் எல்லாம் முடிச்ச அப்புறம் 11 days முடிச்ச அப்புறம் பண்ணலாம்.
Thank you.
Video also we can share, sir.
Okay, thank you very much.
Maybe நான் இல்ல YouTube live கூட வரலாம்.
Super sir.
பட் நம்ம ஸ்டாஃப் இங்க தான் வரணும், YouTubeல பார்க்க கூடாது. ஸ்ட்ரிக்ட் ஆர்டர். நடுல டீன் சார் கூட வந்து போயிட்டாரு. ரொம்ப நேரம் இருந்தா போயிட்டாரு.
ஃபீட்பேக் லிங்க் வர்க் ஆகலன்னு நினைக்கிறேன்.
நல்ல இன்ஃபர்மேட்டிவ் வந்தது சார் எல்லாமே.
சூப்பர், நல்லா பேசுறாங்க.
வாடெல்லாம் நல்லா பண்ணாங்க. இன்னொரு டைம் இருந்தா நிறைய எக்ஸ்பிளைன் பண்ணிருக்கோம்.
ஆமா.
பட் எல்லாமே கவர் பண்றதுக்கு 2 hours
சார். 48 hours, less than 48 hours fixed sir. We fixed everything. நேத்து ராதாகிருஷ்ணன் நானும் தூங்குறதே 2:30 தூங்கிட்டோம்.
அதான் பிபிடி இருந்தா இன்னும் நிறைய ப்ரிப்பேர் பண்ணலாம்.
Sir, okay, sir. Upon can I leave actually? It's already 3 hours over. More than 3 hours, I think. Sir, HOD sir. Sir, HOD sir. Sir, close pantama. No voice. No, I'm not hearing you.
All the participants are given the feedback.
அது பார்க்கலாம் சார். நான் இது அது பார்க்கல ஆக்சுவலி. அது நம்ம அப்புறம் தான் பார்த்துக்கிறோம். முடிச்சிட்டு ரொம்ப நேரம் வெயிட்
And
பண்ணேன்.
also note down the also note down the list of participants because you have to give the e-certificate.
Yes, sir. Yes.
Number 1. Number 2, special attention to be given for our faculty members. Whether anybody is absent
Yes, sir.
today, that we have to segregate. And I heard Dean Science has joined the meeting
Yes, yes.
today.
ஒரு 6:50 இருக்கார் சார்.